changé de masque?
Ça y est, ça y est.
Tu as changé de masque?
Oui, c'est bon, c'est le bon là.
Ah, ok.
Il y a le lien, on le voit pas. Ouais. Pas de problème, je ne veux pas se stresser plus.
Je sais pas s'il y a quelqu'un qui peut envoyer un mail aux étudiants de la promo multimédia, genre sur Discord, pour leur dire que c'est normal que ce soit pas actif. Parce que je pense qu'au bout de 3 quarts d'heure, ils vont faire comme quand c'est en vrai, ils vont partir. Hein? Les 3 heures.
Ouais,
Ouais, tu peux juste leur dire c'est normal et ça vient maintenant. Merci à tous les deux. Je suis vraiment désolée.
Tu peux tenter de...
Ouais. Alors, si je retrouve ma souris. Ok. J'y suis déjà. Ah, ça a l'air d'être de marcher et le lien il devient cliquable.
Essaye de cliquer dessus.
Bah, il tourne. Il tourne. Et ça a l'air d'être bon. Yes!
C'est quelqu'un qui peut tester une chambre par exemple?
Tu dirais, est-ce qu'il y a quelqu'un qui peut se connecter sur YouTube?
Ouais, je suis.
Vous avez le lien sur le site?
Sur ma page web, c'est juste en dessous de...
Ouais, je vois.
Est-ce que...
Cliquez pour... Ah, cliquez pour... C'est juste que je sais pas.
C'est hyper agréable, hein, je reste. Ça va, je suis habituée au bout d'un moment.
Ouais.
Je sais pas.
Mais on a plus bon.
Tu crois qu'on est bon?
On peut y aller?
Ben, je crois, ouais.
Bon, Thomas?
J'aimerais bien vérifier que...
Vas-y.
Il exagère, hein?
D'accord.
Tu veux que je parle?
Oui, merci. Super, je vous entends bien. Bon, par contre, j'ai un écho. Ouais. Je tente. Ouais, non, ça fait un écho.
Bah, tu veux que je... En fait.
On peut couper quand on n'utilise pas... T'es mute, toi, sur ton Zoom?
Oui. Là, par contre, j'entends plus personne. Ou peut-être personne parle.
C'est parce que c'est moi qui ai cassé. D'accord, ça marche. Et on va mettre aussi que quand Peter parle, comme ça évite.
Attends, parce que sans... Vas-y.
On va mettre aussi que quand Peter parle, ça évitera aussi les deux.
D'accord, ok. Là, j'entends ta musique.
Essaie de parler, toi.
Mais comme ça. Mais normalement, le son, il passe par quoi, là? Par mon micro, là? Ok.
J'ai un problème avec le vidéo.
Tu veux que je fasse quoi, là, moi, Thomas?
Du coup, il n'y a plus personne qui parle sur Zoom, c'est ça?
Ouais, est-ce qu'il y a quelqu'un qui peut parler sur Zoom? Ah, super.
Moi, c'est pas super.
Non, c'est pas super.
Moi, je vous entends pas.
Ouais. Ouais, là, j'entends plus personne.
Essaie de taper sur ton micro.
Ça marche?
Ouais, mais on n'entend pas les gens sur Zoom. Sur des raisons. Alors, attends, Zoom. Les gens sur Zoom, il faut régler aussi.
Donc, il y a un écho sur Zoom, en fait.
Il n'y a plus personne qui parle sur Zoom, là?
Attends. Est-ce qu'il y a... Non, c'est...
Il est pas mute,
Moi, j'entends... Ouais, moi, j'entends. Mais vous m'entendez, vous? Ou...
Sur YouTube, on les entend pas. Les gens qui sont sur Zoom. Ah.
Ah. Moi, j'entends bien.
On peut faire un test sur ça? Oui.
Oui? Ouais. Oui, parce qu'en fait... Ouais, que le micro soit coupé de mon côté, c'est normal, en fait. Et c'est normal que sur Zoom, mon micro soit coupé, en fait.
Ouais, mais on n'entend plus les gens sur Zoom. Ok, je pense que là, on est peut-être mieux, là.
Ah.
Vous pouvez parler pour faire un test? Ça marche.
Personne répond. Vous nous entendez là ou pas? Oui, oui, en fait ça c'est normal. Le truc c'est le casque qui me sert juste à écouter moi. Par contre...
Est-ce qu'on peut partir comme ça et tu regardes pendant la présentation
Mais il faut s'assurer qu'ils entendent bien comme il faut depuis Zoom. Parce que j'avais l'impression qu'il y avait des échos pour eux. Ouais. Ah, d'accord, ok. Tu veux que je tape mon micro? Mais... Happy birthday.
Ok, est-ce qu'on peut refaire un test?
Je fais quoi?
Oui, je fais un test pour YouTube, c'est ça? Et ça marche. Est-ce que ça marche?
Ok.
Oh. Settled, it seems. So I will make an introduction in French, and then the rest of the defense will be in English. Okay? C'est tout bon? Bon, bonjour, merci d'être là pour la soutenance d'HDR de Sylvie Chambon. Bon, on a vu les aléas du direct, comme on dit. Donc on est en direct, sur Zoom et sur YouTube, parce que je crois qu'il y a des gens qui ne pouvaient pas se déplacer ici, aussi des membres de la famille de Sylvie. Donc j'espère que par ce biais-là, tout le monde peut suivre sa soutenance. Voilà. Alors moi, j'aurais souhaité qu'elle puisse parler sans masque, mais il paraît que c'est vraiment strictement interdit. Du coup, je suis un peu triste personnellement, mais c'est comme ça. Alors, merci à l'équipe technique pour ce montage complexe. Moi, j'aurais été complètement incapable de faire un truc comme ça. Donc, c'est impressionnant, même si on a un peu de délai, mais c'est quand même vraiment une bonne chose. Alors, avant de démarrer, je vais présenter le jury. Alors, le jury est composé de 2 humains et de 5 hologrammes. Il y a 3 rapporteurs. Donc, on ne va pas les voir à l'écran maintenant, mais peut-être au moment des questions. Donc, il y a Samia Bouchafa, qui est professeur à l'université d'Evry-Val-d'Essonne. Deuxième rapporteur, David Fofi, professeur à l'université de Bourgogne. Et Vincent Le Petit, troisième rapporteur de l'école des ponts Paris-Tech. Puis 4 examinateurs. Donc en Chine, il y a Yi Hongwu qui est professeur à l'Académie des sciences chinoises. Puis en Espagne, Ferran Marquez, professeur à l'Université polytechnique de Catalogne à Barcelone. Ici présente Géraldine Morin, professeur à l'INP de Toulouse, qui est la garante de cet HDR, et moi-même, Peter Sturm, chercheur à l'INRIA à Grenoble. Et j'ai le plaisir de présider ce jury. Voilà. On va directement passer aux questions, parce que le temps pour l'exposer est écoulé. Donc voilà, on a tout le temps qu'il faut, donc tu prends ton temps, et après ton exposé, on va passer aux questions. Voilà.
Okay. Ferhan and Wong, I will say 2 words in French and then I will continue in English. Okay? Donc merci beaucoup pour cette introduction. Merci à toutes les personnes qui ont patiemment attendu depuis 1 heure pour assister à cette présentation et toutes mes excuses pour ce délai. Je remercie aussi toutes les personnes qui sont en train de suivre en ligne. Je sais que vous êtes là, même si vous n'êtes pas présents dans la salle, vous êtes avec moi. Il faut que je vous avertisse en fait que ce matin, normalement, j'avais un cours avec les étudiants de 3e année multimédia. Normalement, c'est une classe inversée, c'est-à-dire que je leur donne le cours et ils doivent me poser des questions sur le cours auxquelles je réponds pendant une séance de cours adaptée à leurs questions. Normalement, le cours avait lieu donc en même temps que la présentation et plutôt que de reprogrammer le cours, j'ai décidé d'intégrer certaines de leurs questions dans les transparents que je vais présenter ce matin. Donc pour les étudiants, pour que vous puissiez vous tenir en alerte, sur les transparents où il y a marqué Answer to a student question, normalement il y a des indices sur les questions que vous m'avez posées. Voilà, n'oubliez pas aussi que vous avez un questionnaire sur Moodle à remplir au sujet de cette présentation. Donc je vais revenir en anglais maintenant. So I would like to thank all the jury members for accepting to participate to this habilitation defense. I would like also to thank all the people who are following this morning the presentation. I have to advise you that the students of the multimedia promotion are following this class. Normally it's a flipped classroom, so some of my slides will contain some answers to their question. Okay, so now I will start. So over the last 20 years, visual content had become more easier and easier to acquire, and also less and less expensive. In consequence, it becomes very interesting to try to automatically analyze all this visual content in order to propose some tools that are useful for people. And in particular, as there are more and more visual content, more and more various visual content, we are able to combine different sources like 2D images or 3D volumes and even videos. So this is why all my research activity is about the analysis of complementary, static, and dynamic visual content. And in order to really highlight the interest of combining all this kind of data. Okay, I don't know if it seems it doesn't work. Sorry. I asked you a few minutes again to be patient. I don't know why it doesn't work. Okay, I will use my mouse. Okay, so the goal of being able of analysis all this different visual content is to propose tools that help humans to understand visual scenes, and in particular, I'm really interested in helping people understanding the environment. I show you this example. Imagine that you have multiple acquisition of a forest scene. So here you can see one image that have been acquired at a specific moment and another image acquired at another moment. Imagine that you are able to segment the different parts of this scene. In particular, you can segment the different vegetations that you can see in this image. You will be able, if you have multiple acquisition, to evaluate how these different kind of vegetation evaluates in the time. And you can evaluate the risk of fire, of a starting fire in this zone. And you can give some indicators to humans in order to do something in order to reduce this risk. So I hope that with this example, you understand that I need to work on 3 aspects of computer vision. Feature detections, also segmentation, and finally matching. So for all my research activity, the main links between all the work I propose is to be able to combine all information sources, but also to be able to combine all intermediate results in order to be able to give a response that combine as best as possible all these intermediate sources and results. And in this slide, I show 3 works that best illustrate this aspect. The first one is what I have done for the registration of scan volumes with nuclear volumes, where I also use a 3D mesh that is showing the briefing model of the patient. The second work that really illustrates very well how I merge different kind of intermediate results is what I have done for urban segmentation, where I combine the result obtained by extracting edges, extracting main planes, and also the skylines. But more important, our major contribution is this work, that is the segmentation by superpixel based on planar elements. And finally, I think that these results really highlight how I try to combine as best as possible all the theoretical results that I can obtain for matching images with different correlation measures. Okay. It's quite obvious, but when you do research, you also need to really well understand the bibliography and the existing works. But what was really important for me is to build a comprehensive bibliography that can be used in my teaching. And this is an example of what I have done next week. In this classroom, I teach some classical computer vision tools like the detection and the matching of point of interest. And in particular, I propose to the students a lab where they have to combine all these images in order to to build a mosaic image, a panoramic image. And for this task, we need to detect and match points of interest. And so what I try to transmit to the student is that more or less all the approaches that you can find in the literature are based on these 3 steps. First, we extract a kind of response map of the probability that each point is a point of interest in the scene. And then, based on this map, you will select first local maxima, and finally, you will refine this result in order to find these blue points that correspond to point of interest. And what I teach to the students is that when you look at research paper, you will find a lot of details of how to evaluate this response map. But in fact, these 2 steps that are not really well detailed in the literature are also important in order to build the final result. Okay, and finally, it is important for me each time I propose a new technique to be able to validate my results. And this is why I always take care of the evaluations and the comparisons. And sometimes, when you have some specific real applications, it's very difficult to evaluate the quality of the result you have obtained. And it was really the case for me when I work on these images and I have to find this kind of defaults, a crack on the road pavement image. There is no data when I start this research, and there are no reference segmentation. This is why I build a data set, and I also propose a reference segmentation. And this work is actually publicly shared and is also referred to a publication. Okay, now after this introduction, I can give you the 3 parts I will follow in my presentation. First, I will present a resume of my whole career. Then, above all the subjects that I have presented in my manuscript, I select only 3 ones that I will develop because they are more or less linked to my perspectives. Okay, so I start with my professional background. After my PhD defense, I stay 1 more year as a temporary teacher researcher in IRIT. And after that, I start a postdoc on medical images. Normally, it was a postdoc for 2 years, but I stopped before because I have the opportunity to have a permanent researcher position in IFSTA in Nantes. So IFSTA is a civil engineering laboratory that is really dedicated to applied research. And it was very interesting for me to work in this lab. But my desire was really to be both a teacher and a researcher, and also to have more academic research. So this is why, after 4 years, I quit and I candidate for this position in NSET. And since 2011, I am an assistant professor in NSET. During all my career, I have the great opportunities to co-supervise 6 students. So the green correspond to students with an academic ground, while the blue one corresponds to an industrial ground. And finally, the purple corresponds to theses that are funded on projects. So the first students I have the opportunity to co-supervise is really in the continuity of my PhD research activities. During my position as a researcher in IFSTA, I really tried to obtain grants in order to have a student on my subject, on my applied subject. It was very difficult, but only 3 months before I leave, I finally obtained a grant. The problem is that I was the only person who had these competencies in computer vision and in image processing. So finally, I continue this work with the student when I was at NSET. And then regularly, I have really a great chance to co-supervise all these students. Marianne was on urban segmentation. Bastien, it's related to skeleton 3D reconstruction. Damien on detection of circular marker, and finally Thierry about the analysis of multiple videos. And I also have the opportunity to work with two postdoctorates, ATEM, which is related to my work on 2D, 3D matching that I will present this morning, and also Shafiq on segmentation of insect images. Okay, so during all my career, I mostly work on these three topics that I already presented in the introduction. And to be more specific, on feature detection, I was really interested on feature in 2D and in 3D. For about segmentation, I really focus on how combine photometric and geometric information. And about matching, I work on also combine all the different criteria that can be used. More specifically, again, I was really interested in studying the complementarity of the different detectors that can be used. And I really focus on the extraction of curvature and what I call the curvilinear saliency. About segmentation, my major contribution was about using minimal path for crack detection. And matching, which is my oldest subject, I work on many aspects, and I will try to describe some of them this morning. But all these tools that I have studied were also used at the intersection of this domain of research, like the curvilinear saliency. I also developed an approach that is based on voting and that combines segmentation and matching. And I think that the work that best illustrates how I combine all these aspects is what I have done on planar superpixels. Okay, I come back to the students I have co-supervised, and I try to show you where they were involved each. But of course, I said that it was co-supervision. So I also have to introduce all my colleagues that work with me on this aspect, and also the colleague outside my team. So I take the opportunity of this slide to thank all these people who work with me. But I also work with some industrial near Toulouse, so I would like to thank these people today. And in France, I would like to show you all the collaborators I have, and I also take the opportunity to thank them. And finally, I do the same in the international collaboration. Okay, and so this is a slide to resume all my contribution on my scientific production. I show you my major reference in a journal, international journal, on all these topics. Okay, so in the manuscript, I have the opportunity to develop the different kind of projects I was involved in. So I have a lot of academic research. I also show some industrial applications. I have shown how I was involved in 2 regional projects and also 2 national projects, and at the end also 2 European projects. And this morning, I have decided to present only 3 topics above all these topics, and this is these 3 topics, because I think it's my work I was most involved in, and it's also related to the perspective I present at the end. So the first topic is about 2D, 3D matching. So I come back to this response map that I show you at the beginning, at the introduction. And so here, this is the way I present the state of the art, and I present the different tools that can be used. And I had this map because I want you to remember that this classification is really based on the way to estimate this response. So we can use many tools, first order ones, second order one. We can also distinguish the approaches that are based on evaluating some criteria on the region around the pixel. And finally, in all these approaches, we can consider multi-resolution. And our contribution is really in the field of second order tools based on multi-resolution. More precisely, we use what we call the curvilinear saliency, that is simply the difference between the principal curvatures. It means that what we are looking for is that it's points of interest that belong to elongated surface elements. And so the higher this response, the higher the probability to be a point of interest. What we had in order to be repeatable from 2D to 3D is that we had a multiscale analysis, and also we use the focus curve concept. Okay. So this is the whole algorithm that we propose. Our goal was to recognize some images, some objects that have been acquired with just a camera, so a 2D image of an object. And what we have is only 3D models of multiple objects. These 3D models are without texture. And you have to understand that we have many models. So our aim is to first identify the right object, and second, to evaluate the pose of this object. So for doing this task, we need to have a common representation that helps us to compare them. And you know that if you just use the curvature information, in the image you will also detect some points that are on the background or on the texture. So we want to eliminate this kind of answer. So this is why we propose a multi-scale focus curve, and we obtain this kind of response that is easier to compare to the response obtained on the different poses of the 3D models. So we do this process for each object we have in our database, and at the end we are able to select the best result over all the right poses of each object. So what was very important in this work is to evaluate how the point of interest that we detect in 2D are repeated in 3D. So these results show you what we have done in order to evaluate how it can help to be more repeatable. So we compare our two methods. So on the horizontal axis, it's on 2D. We compare our two proposed methods with one method of the existing work, and we combine with 3 different detectors in 3D, and the yellow one is what we have proposed. And we showed that the repeatability is better if we use this combination. Okay. This is the kind of result that we obtain. So the goal is to register the 2D image with the 3D model. In the results, I show you in purple the 3D model, and in green the 2D image. And you can see that the two objects are well registered, even if we have some models, some 3D models that are not exactly what we have in 2D. We also compare these results with some deep learning approach, and we have some results that are equivalent or even a little bit more efficient than what we can have with deep learning. So all this work was done in a national project, in a regional project, where the aim is to detect the changes and to detect if I have some problems in the street. I take some picture of the street and I can see there is a problem. So the next step of this work will be to really detect the changes. And it's a very difficult problem, as we have some difference between the 3D models that is perfect and the 2D image that contains some problems. This work was also used in other work that I publish. So this is why I really like this work, because it was reused in some real, in some other application, and in particular in a real application. And what I can do on this work is that we can improve, we can go further if we also investigate other common representation between 2D, 3D. So after I have published this work, I found some other work that is related to this kind of research of a common representation. And in particular, we use the concept of focal curve, and we can also imagine to use some recent work about focal length estimation. Okay, this is the end of the first topic I would like to present to you this morning, and now I will go to the second subject about matching. So, the goal of matching is from each stereoscopic image. We want to find for each pixel of the left image its corresponding pixel in the right image. And the classical way to represent this result is what we call a disparity map. How you can read this disparity map? In fact, each pixel is related to the magnitude of the displacement of the pixel from the right to the left, from the left to the right image. Okay, so the clearer, the bigger the displacement. And the black pixels normally correspond to pixels that are occluded from the left to the right. Okay, so doing this task is quite challenging, as you can have many difficulties, like for example, illumination changes, specularities, and occlusions. So most of my work was dedicated to solve the problem of occlusions, and of course, it is really difficult to treat the problem of illumination changes and specularities, and in most of the approach that exists in the literature, it's a kind of pre-processing before doing the matching. Okay, so more or less you have to estimate this function d that has this profile. And in fact, for doing this task, most of the time, you want to minimize this global energy that is simply composed of two terms, one term for the correspondence, and one term that model the interaction between the pixel in the neighborhood. More precisely, if I develop this formula, what I have to do is to choose a function that is able to evaluate how the pixels that I want to match are closed. And most of the time, for doing that, we just evaluate the intensity difference. The other aspect I have to take into account is what I want to model with the neighborhood of the pixel. It means, for example, I give you an example. If you give a disparity to a pixel, you have to show if in its, you have to check if in its neighborhood the disparity obtained are coherent. And in particular, for doing this, choosing this second term, you can take into account multiple constraints like unicity, the order, the symmetry, also the rank constraints, and what I call the ambiguity and the inaccuracy. And the way to take into account these constraints is can be really different. You can include it in your global cost to minimize, or you can include it at the end of the process by post-processing using these constraints. I have a question of a student who asked me, if I use color, is it better, or the constraints that I will use will work better or not? And I think that the problem is not in the constraints, but really on what you do when you try to minimize the global cost, and you try to minimize the difference, the intensity difference between the pixels. So yes, color can help, but not really when you apply the constraints, but earlier in the process when you try to match the pixel. And it was nice to ask this question because it gives me the opportunity to really quickly present another work I have done. And in this work, I try to understand in which regions of the image color really matters and really had a new information. And what we have found with my colleague in Vienna is that, in fact, color is really important if you have some what we call radiometric areas. Okay? And this is the regions I show in this map. Okay. So usually in the literature, we distinguish global matching from local matching. But what I propose is also to consider what we call multiple matching, because a lot of methods have been developed and take into account multiple approaches. And in particular, I focus on matching based on segmentation. So in this slide, I try to explain how it works. So you have your left and right image, and normally, you can estimate an initial disparity map. What we had in this kind of approach is that we suppose that we can have a kind of segmentation of the image in different regions, and we can use this segmentation in order to refine the disparity map we have obtained. For doing this task, what we do is we suppose that each region of this segmentation map can be approximated by a surface. So for each of these regions, we will estimate the parameter of this surface, and finally we refine the map in order to obtain something like that. And at the end, in most of the approach in the literature, we also had a global optimization in order to refine the results. So it is in this kind of approach that we propose a new technique. And it's really nice because I also have a question of the students, and they say, is there any optimal parameters in order to do this task and in order to use all this method that you present that work for all the images? No. The response, there is no optimal parameter for doing that. This is why the improvement that we propose is, instead of relying on only one segmentation map, we rely on multiple segmentation maps. So it means that you still have a disparity map, but you also have multiple segmentation with obtained with different parameters, different values of the parameters. And for each of this map, you will build a new disparity map. And how does it work? It's exactly the same process at what we can find in the literature. But the difference is that instead of supposing that we have only one surface that can be estimated based on the initial disparity, we suppose that we can have some errors in this initial disparity. And this is why we randomly select some of the points in order to build a surface model and to build a new disparity map. And at the end, we will select the disparity that obtain most of the votes over all the random estimation of the surface. And finally, again, for building the final disparity map, we also use a vote in order to obtain the final result. So at the end, we obtain this kind of results that are quite good when we publish it, and we submitted this result to the Middlebury stereo evaluation, and so we obtained quite good results. So after this work, I was really interested on what we call superpixels, which is a kind of over-segmentation. And I wonder if instead of using this blue square as a correlation window for doing the matching, we can use superpixel in order to change the shape of the correlation window. So this is the kind of results I have obtained that is quite interesting because this image is very difficult to match. We have a repetition of the same object, and we also have something that is really homogeneous. And also, I think that now we have some semantic segmentation based on deep learning that are very performant, and I can hope also to explore this kind of results for proposing new approaches. Okay, this is the end of my second subject, and now I will describe the last subject. As I said in the introduction, it's become easier and easier to have some visual content, and in particular to have multiple videos of the same scene. And when you have this kind of videos, you can imagine that you need to navigate in this video in order to find the video that show you the best point of view from one purpose that you have. Here, in this example, we say that we want to survey an entry of a building, and maybe some of the cameras are more adapted for doing this task. So what we want to do is to try to find the link between the different cameras to evaluate which camera gives the best point of view, and to propose to user the best camera to show, to look at, sorry. So what we want is, based on this collection of videos, we want to obtain this kind of graph in order to help navigation in all the videos available. Okay. For doing this task, we can imagine to use some re-identification tool or 3D reconstruction tools, but the difficulty is that we have a very various point of view, very big differences from each point of view, and in fact, this kind of tools does not work as well as we need for doing this task. So this is why we concentrate our work on trying to identify the different, to evaluate the similarity of activity in the videos. So important assumption about this work is that we suppose that the video are static and synchronized. And we also suppose that we have some previous detection based on well-known deep learning tools, and that we can use this kind of detection as a preliminary result. So the main concept is to say that normally, if the videos are looking more or less to the same scene, we should see some similar activity. So for that, we use what we call the story concept. And the concept is that if I look at the story of all the video I am using, and if I can observe the same activity, or more or less the same activity, I can consider that they are linked. This is why, in this example, the three first camera seems more or less linked, because we can observe the same event, more or less, and whereas the last one is not linked, as we do not observe the same activity. So this is the kind of first results that we obtain. So again, like I said in the introduction, for this task, it was very difficult to have a data set in order to validate our approach. So we build our own data set, and this is the data set we have built. So all these videos are linked. The videos in the blue rectangle are not linked, and this one are not linked also. So what we obtain is the black link that we represent in this video, and we can see that we have only two errors on these results. This is quite encouraging. Okay, the perspectives of this work are really numerous, and this is one of the major perspectives I present in my manuscript. First of all, we have two assumptions. The video are static and unsynchronized. So in order to be really adapted to real application, we need to focus on how dealing with dynamic video and synchronized video. So for doing this task, we suppose that we can detect some events in the different videos. And this is this event that will help us to find which videos are really correlated, and that also can help to synchronize the video. Another aspect I did not discuss in this presentation is that we only focus on the link between video with overlap, but we are also interested in video that do not have an overlap, but that have also a link, because if I have a scene that is visible in one camera, I know that maybe after a delay, the person or the vehicles that I observe will be in front of the other camera. So these links are very interesting too, and we also need to work on that aspect. And for doing all this work, we are really interested in taking into account the background of the scene, because right now we just use the information given by all the elements that are moving in the scene, but we do not take into account the background. Okay, so I have finished my presentation of the 3 results I want to discuss this morning, and now I will present my perspective. So, of course, I want to continue working on combining multiple data and multiple intermediate results. I have worked on many real applications, and in my future I am also very concerned by environment and by helping people. So this is why I want to develop projects in this kind of subject. And you know, since 2010, deep learning-based approach are becoming more and more important. You have seen that I'm like a user of deep learning, but I'm not really working on deep learning approach. And what I want is, in the future, I want to better understand tools that are based on deep learning. And moreover, what I want is really to understand how the classical computer visions that are well known are really linked to these new approaches. So this is, I do not comment this image, but in fact it's just to show you that I'm just a user right now, because I use this kind of detector for the multiple video analysis, and I also use the kind of segmentation based on deep learning in my results. Okay, in the manuscript I have presented all these perspectives. 3 of them are related to directly the continuity of co-supervised thesis. These 2 ones are related to projects I have submitted, and these 3 last ones are related to something that is more long-term perspectives. Since I sent my manuscript, I also submit another project in a Schistera call. And this morning, I have decided to present first this new project I have submitted, and then these 2 long-term perspectives. So I choose to present you this project because it is really in the kind of application I am really interested in. Okay. The goal of this work is to try to propose some tools in order to help forest technicians and also firefighters to not to treat the fire, but really to prevent fire, because there are some action that humans, and in particular experts of the forest, can do before a fire starts. So the goal is to be able to combine all the information given by all the different acquisitions that we can make, and this acquisition can be by drone, by fixed camera, or by also satellite images. And we want helped by forest experts. We want to segment the image to identify how all the different parts of the forest are evolving in order to give them some indication, instruction to do something. As an example, a way to avoid the starting of a fire is just to cut some part of the forest in order to avoid the starting, or just if a fire is starting, just to be stopped by this kind of areas. So for this project, we have, in fact, 3 partners, a French company in Corsica, also my colleague in Spain, another partner in Portugal. And here I put also Italy, which is not really a partner because we cannot really add it in the consortium, but we know that we want to work with him, and so we will work with this partner by subcontracting. And for me, it's really important to put it in the slide because even if it's not a member of the consortium, it's a person as important as all the members. So right now, I don't know if this project is accepted, but it doesn't matter because I already work with the people and I know that even if it's not accepted, we will continue working together. Okay. The 2 last subjects about my perspective are in fact related to PhD students that are starting just right now in October. So for this first subject, our goal is to be able, when we reconstruct the 3D models based on multiple acquisition, we want to evaluate the quality of these models because it's not really well studied in the literature. So what we want is to be able to detect if in the 3D models some aspects are not well constructed or enough defined. And here, on this example of the capital of Toulouse, you can see that in the detail of the 3D images, and in particular when it is textured, you can see that we have a bad estimation on this part. So what we want to do is to evaluate the quality of the model in order to identify this part. And in particular, what we want to do is, based on this measure, to propose to the user the new acquisition he should have in order to improve the models. So it's what we want to estimate how we can choose the next best view. And for doing this task, we really want to introduce some scene semantic analysis in order to evaluate that. And finally, the last subject is within the continuity of what I have presented about 2D, 3D matching. So what I want to do is to propose some approach that is able to compress the data in the same way as you can do it in a comic strip. So I took an example here in this image. You can see first a kind of photography of the man, and then a kind of representation that is generally used in a comic strip. It's the same man, and you can recognize him even if in this representation you have really less information than in this representation. And you can do the same observation with temporal images. In this comic strip, you have only 2 drawings, but you understand that a murder is committed. So we really want to have this kind of analysis, and for doing that, we also want to use scene segmenting analysis. Okay, this is the end of my presentation. Thank you for your attention.
Thank you, Sylvie. So take the time to have a drink, maybe.
Thank you.
I hope you can hear me, the members of the committee.
Yes, we can. I can.
Great. Okay, so we will start with questions, and the tradition wants that it's first the reviewers who ask questions. Okay. So we would start with, well, alphabetically order and also gender order with Samia Bouchafa, so professor at Université d'Evry-Val-d'Essonne. Samia, okay, tu peux poser les questions.
Merci, Monsieur le Président. Alors, je vais peut-être poser mes questions en français, sauf si il faudra peut-être que je traduise de temps en temps. Vous m'entendez?
Oui.
Oui, j'entends.
Alors, donc, merci d'abord pour l'invitation. J'aurais préféré évidemment être sur place. Alors, l'avantage, c'est que je me présente à vous non masquée. Bon. Donc, j'ai une caméra qui n'est pas au même endroit que mon écran. Donc, de temps en temps, je ferai des allers-retours pour essayer de me présenter à vous face à face. Donc, je voulais d'abord, Sylvie, te remercier pour cette présentation qui était très, très claire. Très didactique, hein. On voit bien qu'il y a un véritable goût pour la pédagogie. Merci donc pour cet exercice en live hein, de démonstration de classe inversée. Je ne sais pas quel sera le bilan, mais en tout cas, c'était très original d'inviter les étudiants à travers cette présentation à participer d'une certaine manière. Je vais peut-être commencer par faire des remarques sur le manuscrit en tant que rapportrice. Donc j'ai trouvé que le manuscrit était très riche, présenté de façon un peu inhabituelle, c'est vrai, puisque on retrouve en fait toute la partie parcours en annexe. Mais la partie scientifique est extrêmement riche et développée. Elle est présentée avec beaucoup de générosité. Alors, ce souci constant de guider le lecteur, de proposer plusieurs grilles de lecture. J'ai aussi apprécié le fait que les résultats qui proviennent de travaux collaboratifs, de projets avec étudiants encadrés soient systématiquement mentionnés. La bibliographie aussi est très riche, notamment dans la section perspective, même trop riche, hein, ce qui donne beaucoup de perspectives et des points d'entrée finalement vers la bibliographie qui correspond aux perspectives qui sont présentées. Alors j'ai trouvé aussi qu'il y avait carrément certaines parties qui pouvaient constituer des cours de référence hein, pour des nouveaux doctorants, tellement elles sont bien documentées et bien détaillées. Donc ça, c'était vraiment les remarques générales concernant le manuscrit. Alors, en ce qui concerne maintenant les remarques générales aussi sur le parcours, sur le travail, donc je voudrais saluer vraiment le lien fort entre formation et recherche, on l'a vu aujourd'hui à travers l'exercice de classe inversée, et que l'on voit aussi à travers les sujets de projet qui ont été proposés hein, durant toute la carrière. Alors, donc, il y a cette formidable implication dans les nouvelles pédagogies, de nombreuses collaborations nationales et internationales. Il y a ces fameuses contributions méthodologiques qu'on a bien vues aussi aujourd'hui, mais aussi applicatives, puisqu'il y a eu plusieurs applications qui ont été travaillées, donc la détection de points 3D en imagerie médicale, de la segmentation de scènes urbaines, de la détection de fissures, de la segmentation d'images d'insectes. Donc c'est très varié, même en termes applicatifs. Voilà, donc de nombreuses perspectives aussi, avec plusieurs nouveaux sujets de thèse en perspective. Vous êtes, je pense, tranquille pour plusieurs années. Voilà, donc ça, c'était les remarques générales sur le parcours. Donc, je vais commencer par quelques questions. Alors, je ne les ai pas trop triées. Peut-être quelques questions un peu générales. Alors, une question relative au titre. Donc, il y a dans ce titre cette fameuse notion de complémentarité. Donc, ma première question, un peu générale, hein, je l'avoue. Est-ce qu'on peut définir finalement la complémentarité de manière indépendante de la tâche? Est-ce que, par exemple, des détecteurs peuvent être complémentaires pour une tâche de mise en correspondance et ne pas l'être pour une tâche d'estimation de pause, de reconnaissance? Donc ça, c'était vraiment, est-ce qu'on peut décorréler la notion de complémentarité avec l'objectif en termes de tâche vision, entre guillemets? Et qu'en est-il finalement de la redondance? Est-ce qu'on ne peut pas envisager de l'exploiter dans le processus de décision, puisque là, seule la complémentarité a été étudiée? Voilà, ça c'était ma petite question générale en lien avec le titre.
Ok, est-ce que vous m'entendez bien là ou pas? Si je parlais, il y a un écho, ouais. Ok. Est-ce que c'est bon comme ça? Ouais.
Parfait.
Donc merci beaucoup déjà pour tous ces retours très positifs. Et voilà, merci beaucoup pour ça. Alors effectivement, la question de la complémentarité, ça a vraiment été quelque chose d'important dans tout mon travail de recherche. Et c'est quelque chose que j'ai regardé aussi bien pour les détecteurs que pour les mesures de corrélation notamment. Hein, j'en ai pas trop parlé ce matin. Et c'est vrai qu'à chaque fois que j'ai fait ces études-là, c'était plutôt dans un cadre, sans application très précise. Et après, ce que j'ai fait sur les détecteurs, ça s'est vraiment appliqué à ce que j'ai montré, là où on essaie de reconnaître des objets dans une scène à partir de modèles 3D. Mais de manière générale, à ce stade-là, ce n'était pas vraiment appliqué. Et moi, en fait, ce qui m'intéressait, c'était plus de trouver vraiment les endroits des scènes où certains détecteurs vont donner une réponse alors que d'autres ne vont pas en donner. Et la même chose pour les mesures de corrélation. Donc j'ai vraiment, c'est vrai, focalisé mon travail sur ça. Et je pense que ce que j'ai fait, c'est assez général si on suppose que l'objectif, c'est vraiment de couvrir toute la scène. Mais je suis d'accord que si l'objectif, c'est pas de couvrir toute la scène, peut-être que toute l'étude de complémentarité que j'ai faite, elle est un petit peu décalée par rapport à cet objectif. Et après, sinon, sur le fait, je voudrais revenir aussi sur l'aspect redondance évoqué dans la question. Et c'est vrai que j'en ai pas trop parlé parce que j'ai pas pu aboutir, on va dire, sur ce point parce que par manque de temps dans mes recherches. Mais c'est quelque chose que j'avais commencé à regarder, notamment sur la combinaison de mesures de corrélation. Et il y avait vraiment cet aspect que il y a des zones où seules certaines vont nous donner la bonne réponse et il va falloir réussir à déterminer que c'est bien elles qui nous donnent la bonne réponse. Et à l'inverse, il y a des zones où on a plusieurs mesures qui vont valider une réponse. Donc c'est aussi important d'évaluer cette redondance et d'en tenir compte en fait dans l'algorithme de décision pour fusionner les différentes approches. Donc c'est vrai que quand même, moi j'ai surtout travaillé sur la complémentarité et j'ai pas vraiment travaillé sur la redondance d'informations, mais c'est une remarque totalement justifiée et qui mérite clairement d'être aussi étudiée.
Merci pour la réponse. Oui, effectivement, moi je suis convaincue que ça ne peut qu'apporter des informations qui peuvent être intégrées dans le processus de décision. Alors, j'ai une autre question très générale. Donc, quand on lit votre manuscrit, on se rend compte en fait que tout est lié, en fait. Détection de primitives, segmentation, mise en correspondance, chaque processus peut tirer profit des autres. D'ailleurs, dans les perspectives, vous mentionnez une segmentation et une mise en correspondance conjointe. On voit bien vraiment que tout est lié. Donc, quand tout est lié, se pose la question de l'évaluation, de la défaillance d'un des processus, entre guillemets, dans un système complet. Et c'est vrai que... il y a peut-être eu des études par-ci, par-là, par exemple sur la détection des primitives 2D. Ça dépend quand même beaucoup de la pré-segmentation des images, dans quelle mesure finalement la qualité de la pré-segmentation va influer sur le résultat. Donc ça, c'est dû au fait que tout est lié en fait dans votre travail. Donc est-ce que vous avez des perspectives sur justement les liens, enfin l'évaluation du système et l'étude des défaillances d'une partie par rapport aux autres, etc.
Ok. Je reviens de réaliser que je réponds en français et qu'on fait tout en français alors qu'il y a 2 membres du jury qui parlent en français. Donc je vais traduire en anglais la question et je vais répondre en anglais. Okay, Ferhan and Iwong, I'm sorry because I realized that the first question was in French and I did not translate and I answered directly in English, in French. So sorry, I will not come back to the first question, but now for this question I do it in English. So the question of Samia is that, okay, you want to combine the different tools, segmentation, feature detection and matching, but how you can really evaluate the contribution of all these tools, and do you have any perspectives in that sense? It's okay, Samia, it's the good translation? Okay. Okay.
I'm sorry, it's my
yes,
fault.
I totally agree with you. It's really a problem when you combine multiple tools. At the end, you obtain a result, but you are not able to say to which tools or which parts your algorithm obtain good results. So it's clear that I did not present that aspect on the manuscript because it does not correspond to the element I developed. But I have to say that in particular when I work on crack detection, at the beginning I really use a lot of tools, I combine a lot of aspects, and each time I really try to evaluate how each one contributes to the results. But clearly it's really a difficult task because it's difficult to separate and it's difficult to evaluate the interaction very, very well. But I have to say that I really do this job. And in particular for the voting scheme approach that I also present this morning, I really reduce all the work that have been done by Guillaume, but it was also a big question during all his thesis because the initial goal was to match some seed point in the image and then to propagate. And for doing this task, we starting by trying to identify the detector that are the most complementary, and then when you have this seed, how you can propagate, etc. So sure, it's a lot of work, and sometimes it's even not really possible to do it correctly. So this is for my already published work. And now for the perspectives, clearly it's still a difficult problem, and right now I don't know exactly how we will do it, but it's sure that we really have to evaluate separately how each element contributes to the final result. And yes, I can also develop another example. It's the work I have done with Thierry about the analysis of multiple video. In this analysis, we also have a matching process. And so we really try to evaluate separately this matching process. And what is difficult is that we also have to have a reference matching, and this is one of the difficulty. So we have to click on some points on the scene in order to evaluate how it works. But yes, I totally agree with your remark, and I think for my future work I will continue thinking of this aspect, but I think it's a really challenging aspect.
Thank you. Okay, so I have another question concerning descriptors. So it is related to the 2D detection, primitive detection part.
Excuse me, Samia, can you just starting from the beginning, because I have lost the beginning of your question, so I cannot understand.
Okay,
Sorry.
I will ask the question in French, and maybe I will try to translate, or maybe you can help me after.
You can say it in French if you want, and I can translate it. I think it's easier for me.
Thank you very much. Donc j'ai une question concernant la question des descripteurs dans la partie toujours détection des primitives 2D. Donc elle a été évoquée dans le manuscrit, hein, vous étiez bien consciente qu'à un moment donné il fallait s'y intéresser. Donc là ma question c'est vraiment, on peut très bien avoir des détecteurs complémentaires au sens de la complémentarité qui a été définie, donc gain de répétabilité, gain de répartition spatiale, etc. Mais avec peu de descripteurs associés ou peu discriminants finalement pour une tâche de mise en correspondance. Alors, est-ce qu'il vaut mieux pas avoir un détecteur associé à des descripteurs qui sont discriminants ou plusieurs détecteurs complémentaires avec finalement peu de descripteurs discriminants? Voilà. Okay. Donc, c'est toute la question de l'ajout des descripteurs et voilà, de peser comment dire, le bénéfice finalement de travailler que sur la complémentarité en mettant un peu de côté la qualité des descripteurs.
Okay, So I try to reformulate. What you say is that I work a lot on the complementarity of the detection, but I did not really discuss about the description and the characterization. Okay, and how can I go further on this aspect? So it's true that I did not explain that aspect this morning, and I think I explained it, but a little on my manuscript. So clearly, in the literature, traditionally, people detect points, but they did not really talk a lot about the description. And I think that the first work that really do this job is the work of Love about the SIFT technique, because they really both propose a detector and a descriptor. And after that, a lot of work is also developed about how building some descriptors. And I think that in deep learning approaches, actually, the main focus is really on the description. So you're right. I think that it's also interesting to study the complementarity of the descriptor. And I think that I have started a little to work on that aspect with the work of the 2D 3D images I presented this morning, but I only discussed about the wall application and all I didn't get into the details. But we also work on the description, not based on the histogram of gradients, which is a classical descriptor, but we adapt this descriptor to the curvilinear saliency. I also work on this aspect on insect segmentation, and it's clear that we try to combine multiple descriptors. But yes, I think that you're right. You definitely need to evaluate how the different combination of descriptors can help to the matching process, in fact. And right now, I have no expertise on this aspect. But you're right; it's also another aspect to study in the fact that we want to study the complementarity.
Merci.
Ouais.
Alors, j'avais une question, je vais essayer de résumer un peu, sur la segmentation photométrique et géométrique. Alors, dans l'algorithme d'appariement par propagation de germes, alors j'ai trouvé la méthode très astucieuse. Alors, j'aime beaucoup ces approches où il est question de décider en fonction de critères de fiabilité, etc. La question du temps de calcul, elle a été évoquée en disant dans l'intro, je crois, que c'est quand même moins coûteux qu'une mise en correspondance classique et qu'il faut quand même trier des germes par fiabilité. Est-ce que vous avez étudié un petit peu la complexité de cet algorithme en fonction du nombre de germes, de leur répartition spatiale, etc.
Okay, so the question is, I have worked on approaches based on seed propagation, and in the result we pretend that more or less is less time consuming than a global classical approach. So I have to admit that this work is totally theoretical, so that's true that we did not really evaluate a lot the computational costs of this approach. But so I cannot answer precisely to this question. I'm sorry, but what I can say is that clearly, as it's a propagation, we don't have to investigate the same number of pixels as a candidate. So by definition, it's less time consuming. But I have to be honest, I don't evaluate exactly the complexity.
Ça fera partie des perspectives. Toujours dans cette partie, appariement par vote, donc là, le processus, il n'est clairement pas déterministe, il y a un tirage au sort quelque part. On peut l'éviter, ce tirage, ou pas? Parce que j'ai commencé à regarder en me disant, est-ce que c'est possible de l'éviter? Est-ce que vous avez des idées là-dessus ou pas?
Je ne comprends pas le terme et je ne vois pas ce que ça veut dire éditer en fait.
Éviter, parce que
l'éviter.
Le problème, c'est vraiment le tirage.
So the question is is it possible to avoid the random selection? Okay.
Parce que là, vous ne pouvez pas
I don't
obtenir...
know. Honestly, for me, it's a part of the algorithm that is interesting because the main idea is that I will do it as much as necessary to finally obtain the right answer, and so I don't know. Maybe we can imagine to use a point of interest again instead of just randomly select some points that have no specific characteristic. Or maybe we can use the seed we also define in the previous approach. I think that one of my perspectives in the manuscript is that maybe, because this is the work of the same student, and we work on seed propagation and then on the voting scheme. And I think that what we have done on the seed propagation, and in particular the complementarity of the detectors, can be the new seed or the points that are selected in this voting scheme. Maybe, I don't know.
Ok, thanks. Toujours dans cette partie, donc il y a cette segmentation qui est ensuite utilisée avec la carte de disparité. Donc ça veut dire qu'en fait, je voulais savoir dans quelle mesure l'hypothèse qui est que la frontière des objets en termes photométriques devait correspondre à la frontière en termes de profondeur finalement. Est-ce qu'il y a eu des évaluations où ça concordait peu, frontières photométriques et frontières en termes de distance?
Okay, I try to rephrase. What you mean is that is there any evaluation in order to evaluate how the edges of the segmentation are really matched to the contour of the object in the scene? Not really. We did not really evaluate this aspect, but and I think it's quite difficult to evaluate that. But yes, I'm thinking. Sorry. Yes, I think that maybe based on the ground truth that we had, and if we suppose that we have a reference segmentation that we validate, we can do this kind of evaluation. It's very interesting to ask that. And to answer a little bit to this question, I think that the fact that we use multiple segmentation, it's really because we know that this preliminary result of segmentation is not as reliable as we want. So it's a less reliable result. So this is why we use multiple segmentation in order to be as robust as possible to these results that can be a little bit erroneous on some areas of the image.
Merci. Alors j'avais des questions aussi sur quelque chose qui m'intéresse plus, mais je pense que ça fait vraiment partie des perspectives intéressantes, tout l'aspect intégration de l'information temporelle, prise en compte plutôt de vidéos, plutôt d'images statiques, etc. Donc j'ai trouvé intéressant que vous évoquiez tous ces aspects-là dans les perspectives. Alors, je vais peut-être aller... je pense qu'on est nombreux dans le jury. Je vais peut-être aller vers ma dernière question ou l'avant-dernière. Je vais en sélectionner une. Oui, la dernière, allez. Donc, c'est plutôt une remarque ou c'est juste un sondage pour avoir un peu votre avis. En lisant votre manuscrit, on a vraiment l'impression que vous faites partie d'une école de pensée en traitement d'images, en analyse d'images, qui est l'école de spécialistes en analyse d'images. C'est vraiment une analyse très fine, proposer de nouveaux algorithmes de décision au plus bas niveau, beaucoup de modélisation. Alors, c'est une école qui se fait de plus en plus rare depuis le succès des techniques de deep learning, bien sûr. Et vous proposez beaucoup de perspectives dont l'objet est d'intégrer ces techniques d'apprentissage. Alors, je me dis parfois c'est un peu dommage, mais en même temps, je me demande ce que ça va donner, l'alliance du deep avec une démarche vraiment très analytique. Je pense que ça promet de belles perspectives finalement. Alors, je ne sais pas ce que vous en pensez personnellement.
Okay, so the question is finally how I link my work that is really in the computer vision classical tools and deep learning. Okay, so personally, when deep learning approaches emerge, I was not really interested because, of course, I really like to work with my classical computer vision tools. And so at the beginning, I don't really take care of deep learning approaches. And then it becomes more and more important. And I went to conference, like, for example, RFIA in France, and I realized that 95% of the presentation were based on deep learning. So I say, okay, I cannot ignore that the world is changing. I cannot ignore that I have to adapt to this world. So this is why I decided to start to take care of these approaches. And I realized that there are many, many aspects on a deep learning-based approach. And so at the beginning, it's just really to learn for myself. I was not really thinking of using it. And then it becomes also obvious that some approaches give so nice results that I have to use it. And in particular, with the work of Thierry on multiple analysis, we want just a simple detector, and it seems really natural to use a deep learning-based approach. So I think that I really want to better understand this approach and really to find the link between what I well known and this all this domain that I do not know well. And so I don't know really how it will evaluate, but really it's my perspective for my future work. And I don't know exactly how it will work or not, but I think I have to. And I think I have to, but it's also interesting. It's not just an obligation.
Thank you. So we will pay an attention to your future work on this subject. So I have finished. Thank you very much for your very nice presentation and for all the answers to my questions.
Samia. Thank you.
Thanks. Bye.
Oui, merci. Thank you, Samia. So the second reviewer who can ask questions, I think it would be David Fofi. David?
Yes.
Switch on your camera. Oh, it's done. Thank you.
Hello.
Tu veux que je fasse quoi? Mais on les voit pas. Ah, les afficher en plus grand. Ok. Je sais pas. Comme ça. David, on essaie de t'afficher en plus grand.
Oh bah,
que tout le monde puisse t'admirer.
C'est bien utile.
Peut-être que je vais arrêter de partager sinon, mais je pense que le partage, ça m'interdit en fait de les passer en full screen. Ça c'est bien? Ok, super. Super. Donc, attends, peut-être.
C'est bon.
C'est bon.
Comment veux-tu qu'on procède en français et tu traduis ou tu veux que je parle directement en anglais? C'est comme ça t'arrange.
Ben, attends. Ouais. Je pense que je préfère que les questions soient en français, comme ça me permet de les reformuler, d'être sûr que j'ai bien compris, et après je réponds en anglais. Je trouve que c'était pas mal avec Samia.
Super, très bien. Donc d'abord, tout d'abord, merci de m'avoir invité pour ton jury d'HDR. Je suis vraiment désolé de ne pas être là. Hein. On a eu 3 occasions de se rencontrer cette année, on les a toutes perdues. Vivement l'année prochaine. Mais voilà, donc là c'était un petit peu un cas de force majeure. Tout ça va s'arranger. Je vais commencer peut-être par quelques commentaires sur ton travail, sur à la fois le manuscrit et sur la soutenance. Alors mon premier commentaire c'est waouh. Vraiment, enfin, j'ai été assez impressionné par le manuscrit, son étendue, son exhaustivité en fait, et puis la forme que tu lui as donnée, effectivement, c'est original en fait pour une HDR. J'ai lu des HDR qui étaient plus courts que le titre. Et c'est vraiment, en tant que lecteur, on se sent à la fois respecté, informé, et ça a été vraiment un plaisir. Ça a été long, mais ça a été vraiment un plaisir de lire ton travail. Et on est bien guidé en fait par la structuration que tu lui as donnée. Moi, je pense que je l'utiliserai, si tu le permets, pour certains cours de master, parce que c'est vraiment bien construit et il y a le lien entre l'état de l'art et tes contributions propres qui est fait de manière très très smooth, douce, et qui permet une lecture vraiment très très aisée. Donc c'était vraiment un plaisir. Et puis ton exposé oral, c'est tout l'inverse. Alors en termes de qualité, c'est aussi bien, hein, mais c'est très synthétique. Tu as fait des choix, tu as fait un cours, et là encore, on a appris des choses. Enfin, moi, j'ai appris des choses. Et j'ai trouvé ça vraiment, vraiment bien. Donc merci beaucoup. J'ai passé jusque-là un très bon moment. Sur le fond, comme l'a dit Samia, moi j'ai beaucoup aimé le fait que tu relis systématiquement l'enseignement et la recherche. Parce que l'enseignant-chercheur, c'est pas travailler 50% de son temps dans l'un ou dans l'autre, c'est être le tout à la fois tout le temps. Et on l'a bien vu. Pour une HDR, parfois, on force un peu le côté recherche. Là-dessus, bah, tu as des billes et puis tu as plein de choses à dire. Et tu en as dit plein, mais sans perdre le lien avec la transmission, sans perdre le lien avec les étudiants et sans perdre le lien avec l'aspect enseignement qui est important et qui fait partie de notre travail. Sur l'aspect plus thématique, moi j'apprécie vraiment la consistance en fait sur le temps et la cohérence de tes travaux. C'est voilà, tu as atteint une expertise qui est pas courante en fait sur un domaine, comme l'a dit Samia, l'analyse d'image qui est important parce qu'il est fondamental dans nos disciplines et tu as acquis au fil du temps un profil quand même très très singulier et très très intéressant. Donc tu marques de ton empreinte la discipline, je trouve, et pour ça aussi je te félicite. La façon aussi dont tu as eu déjà d'intégrer tes étudiants à cette soutenance, de faire un cours inversé pendant ta soutenance d'HDR, c'est aussi c'est osé, c'est bien, et tu communiques pas que des connaissances, hein, tu communiques aussi ta passion et ta façon de voir je crois ton approche du métier. Et c'est encore une fois très, très enrichissant pour ceux qui t'écoutent. Et bravo pour tout ça. J'ai quelques questions, évidemment. Je vais commencer par une question qui est en lien avec la dernière question de Samia sur le deep learning. Moi, j'aimerais savoir dans ton travail, en fait, comment tu as évolué toi-même au sein de ta discipline, comment l'essor du deep learning et l'aspect un peu hégémonique qu'il a pris a affecté ton propre travail et comment il a changé ta façon de voir tes propres axes de recherche, ta propre façon de penser, en fait, ta discipline et tes méthodes.
Du coup, je te laisse. Okay. Merci beaucoup déjà, David, pour tous ces retours très positifs. Ça fait du bien entendre. Ok, je vais reformuler en anglais. So the question is how the emergence of deep learning has really impacted my work. Is it a good reformulation? Okay. Okay, so I will continue in the same spirit of my previous answer with Samia. I think that what is really different from me is this learning phase, because in all the aspects I have already studied, I don't really have learning. So, and this is independent from the deep learning. It's really how I can had this task of learning in all the process I already work on. Honestly, it's not really, I'm not sure I will give the right answer, and I'm not sure of the right answer, but the first step for me is really how, with all the application I work on, how I can collect a database, how I can use already existing database. And right now I do not have exactly the answer. And I give you an example of that is I work on insect segmentation, and it was very hard because I start by using curvilinear saliency to have a first detection, and I think it was a nice tool for doing that. And then we really want to classify between insects that are the insect of interest, because in this application we are searching for a butterfly that is called Eudemis. And so I want to use learning in this first application. It was, I think, 3 years ago. And I was thinking at that moment that using deep learning will be a good option, but honestly, it was really difficult for me to use it correctly. First of all, the first idea is that I have no consequence database on this subject. So at that moment, I don't understand how I can use this kind of techniques. So this is why I started to learn and to understand how it works. And after that, I realized that I can do something if I am able to augment my database. But at this moment, 3 years ago, I was not really aware of these techniques. So finally, I proposed a classical approach based on support vector matching, but I was not totally satisfied by this proposition. So this is it's not a general answer to the question. It's just an example. I don't know exactly how to give a general answer to this question. Right now, for me, it seems very important to focus on this kind of techniques. But I don't know exactly how we will have a great impact on my research. I think that the first point is really, I want to understand in all these techniques. When I look at an architecture, I want to understand how the different steps of this architecture are linked to what I know about my own computer vision tools. And right now, I understand some aspects, but clearly I miss some other aspects. And this is the kind of question I want to answer.
Est-ce que tu crois que sur certains aspects du travail que tu as traité jusque-là, ou tu t'apprêtes à traiter, le deep learning peut être complètement inopérant?
Tu peux répéter, j'ai pas entendu.
Sur certains aspects de ton travail, passé ou même futur, est-ce que tu penses que le deep learning peut être complètement inopérant? Pas utile du tout.
Yes, so the question is that do I think that some deep learning approaches are not adapted at all to some of the problems I try to solve? Is it the question?
Yes.
Okay. So it's very difficult to answer, but I think I try to give some answers about that in my presentation, but maybe it's a little bit discreet. But honestly, I was very surprised that the results I obtained for 2D, 3D matching finally as good as deep learning approach. So I don't know exactly in which technique deep learning will not bring something interesting, but I'm quite sure that in some aspect it's not really relevant to use deep learning approaches. I think that another answer is that deep learning, I think, brings something when we really don't know how to characterize our problem. We really don't know, we cannot describe or explain exactly what we are searching for. And I think that in this case, deep learning is useful. But if you know that you want to find a specific object with this characteristic and you can explain the characteristic, I don't think that deep learning is useful.
Merci. Quelques questions sur le caractère peut-être multimodal de tes approches. Est-ce que tu as traité jusque-là, ou est-ce que tu as adapté franchement tes algos ou tes méthodos sur des jeux de données multimodaux? Déjà, première partie de question.
So the question is for taking into account multimodality, did I really adapt each tools or to each modality? Is it the question?
Pas vraiment. Est-ce que les outils ont été pensés pour prendre en compte une multimodalité dans les données? En gros, du RGB avec une autre modalité d'image. Alors, tu fais du 2D, 3D, c'est une forme de multimodalité, mais l'infrarouge plus du RGB, par exemple. Comment tu vois les performances ou l'application de ce que tu as développé? Alors, sur des exemples précis, hein, ça peut être le matching, ça peut être la segmentation, enfin, notamment le matching, d'ailleurs. Comment tu vois ces applications-là sur un jeu de données qui serait complètement multimodal, et qu'est-ce qui manquerait, s'il manque quelque chose à tes travaux pour y parvenir?
Okay, so the question is how can I adapt the proposition to real multimodal treatments?
Mm-hmm.
Is it that? Okay. I think that we have multiple options for doing this task. We can consider that we have generic tools that really work on all kinds of data. And we can consider what I have done. We can consider that we have a common representation and we will do something in this common representation. So I think it's not directly useful for any kind of modalities. I think that we always have to find a kind of space to represent all the data in order to extract some information for matching or just for feature detection or for segmentation. Right now, I don't know how to really have a tool that is generic to all kind of data. I don't know if I answer well your question.
Yes.
Okay.
Dans tes perspectives, tu présentes le projet sur les feux de forêt. Mm. Il me semble qu'il y a de la multimodalité là-dedans. Mm. Comment tu vas l'aborder? Je peux voir des images.
Right now, I don't know exactly. So the question is, how can I combine the different kind of information I will have for the project about fire prevention? Right now, I don't know. I really want to study how the different tools I have made can work on the different modalities, and I hope that this first result will help me to find how to combine them. On this project, I will really focus on what I am interested on, the segmentation, matching, and feature detection. And there is also part that is dedicated to artificial intelligence to make the decision to alert or not sur the risk of the region. But me, I will really focus on the segmentation aspect in order to identify the different vegetation. And I really want to match images from an image to another in order to evaluate the evolution. And what I expect is that, again, the information will be complementary. And so I think I will not detect the same things on the optical images and on the other kind of images. And I will combine the different criteria that can be extracted on these different images. This is or data. This is the interest of the project, is that really we do not observe the same aspect on the different acquisition, and we have to merge all this information in order to take the decision. So it's more in this way I was thinking of using multimodality and not doing the same task in all the modalities. I don't know if I answer well. Okay.
Sur l'aspect combinaison 2D, 3D ou traitement conjoint, enfin, est-ce que tu as abordé déjà, est-ce que tu as appliqué des méthodes sur un flux RGBD? Ou est-ce que ton 3D, c'est un modèle 3D propre, yes. CAO?
Yes, I only apply it on a RGBD, on a 3D model, and not on a RGBD acquisition. And honestly, I don't know if it will be the case, but I hope that I will use it on RGBD during the thesis of Rémi. It depends on my colleague if they agree on that, but it was one of my ideas. So no, directly I did not apply it to RGBD.
D'accord. Et alors, sur certains traitements 2D, on applique un noyau de convolution ou autre sur l'image. En général, il est fixe. Et parfois, on aimerait bien le relier à la profondeur pour utiliser la profondeur comme facteur d'échelle peut-être des traitements. Est-ce que tu as réfléchi à des choses comme ça déjà? Est-ce que ce n'est pas si important que ça en fait? Est-ce que la plus-value elle n'est pas décisive? Voilà. Est-ce que tu as des choses à dire là-dessus?
Yes, I think that the proposition, the initial proposition based on multi-scale focus, is really to try to find a relation between the size of the convolution mask or the size of observation and the focal length. So our work is more or less in that aspect, and I think we have to go further in this work because it's just can I say it's a preliminary results, but yes, it's the idea. So I think I will continue working on that aspect too.
Sur l'aspect maintenant peut-être multi-vidéo, donc tu as présenté tes travaux avec, il y a un réseau de flux vidéo avec sans recouvrement et autres. Est-ce que tout ce dispositif te permet de remonter proprement à la 3D de la scène?
No, it's a good question because it was the first thing that we tried to do, and the point of view are so different that it's really difficult to extract a 3D reconstruction. So I don't show it in my presentation, I think, but maybe in the manuscript. So we decided not to work on that aspect. And it's also a perspective of this work because it was very frustrating not to have a 3D reconstruction of the scene. And after that, with Thierry, we find some publication, in particular with deep learning approaches, that can maybe be used in that sense. But no, we cannot, right now with the classical tools, we did not manage to have a good 3D reconstruction of the scene.
Vous étiez loin du résultat ou les résultats n'étaient pas satisfaisants seulement? C'était pas adapté ou c'est les performances qui n'étaient pas à la hauteur de ce que vous attendiez?
We more or less we obtained a 3D exactly from this scene. More or less we obtained a 3D reconstruction of the scene, but for doing that, at the end we finally click some points in the image. We use if I remember well, we use the this place on the parking in order to make the reconstruction. And then we also try to have automatic detection of point of interest and to match them. But I remember that it doesn't work at all. It was really the mess. It was impossible to exploit.
Ok. Merci beaucoup. Je crois que j'en ai fini avec mes questions. Je te félicite encore et puis merci pour tes réponses.
Merci.
Merci, David. So, next person to ask questions would be Vincent Le Petit.
Thank you, Peter. Should I speak French or English?
It's as you prefer, David. Maybe Vincent. I don't know. It's written with David. It's as you prefer, and maybe if it's in English, I will have to rephrase. I don't know. It's as you prefer.
If it's in French, you mean? Okay, so I'll try to do it in English. So that's probably a little bit easier to follow for the for the rest of the committee. Okay. I will do it with the French accent anyway. So that's. But so yeah, so just to say that. So first of all, so I'm sorry not to be with you today. So I will miss the Toulousain food this for lunch. But also yeah, so that would have also be nice to meet you, to meet also Peter. But yeah, so times are a little bit difficult. But thank you for the invitation. Thank you for the presentation, for the manuscript. The manuscript was very clear, very pedagogic. So it's you did you did so many things, but it's still very fluent, still very easy to read and to understand. So that was really a pleasure to read it. You covered a lot of topics and different topics. So there are already things I already said in my letter, so in my report, saying that you did. I really like your pragmatic approach where you really evaluate or reevaluate existing approaches. So that's something which is very important before you develop your own. And so that's something that not many people do, and that's important in science. And so also, yeah, so the practical application, so that's also very important. So there are so many theoretical works these days, or theoretical in the sense that they have a benchmark, they develop a method specific for the benchmark, but they don't really apply it to real data. And that's really a pity, because that's the real test, and you actually do the real test, so that's really important. So that's I hope we'll get back to these kind of things in the literature, but it's so that's the influence of benchmarks is really too important. So that anyway, so I will not be too long for the compliments, but. I will ask a few, but even if I think a lot of goods about your work, I will just ask a few questions. Yeah, so I'm sorry. I will go back to machine learning and deep learning. Not necessarily deep learning but machine learning in general, because it's true that it influenced a lot of the development of computer vision and image analysis. Over the last years. So it's true that you didn't really use machine learning or just maybe deep learning at a high level, but it's okay for me in the sense that I really believe that what you develop still has advantages to compare to deep learning approaches, but maybe we can try to detail that a little bit. So, for example, on your work on the 3D object detection post-estimation, so there is a lot of methods using deep learning, of course. So I know that you did some comparison, but how would you defend your approach to a deep learning person and to convince them that your approach is still interesting in the times of deep learning. So let's focus on this example.
Okay. It's a hard question because honestly, it's really difficult to.
I think you actually, if I ask the question, it's because you have a very good answer. But,
can you repeat because I removed the.
there is actually a very good answer.
Yes. The good answer is that I obtain interesting results that are comparable to deep learning approach, I think. Is it what you are thinking?
No, so that's but more, of course, so you can do the experimental evaluation, but
and yes, another aspect is that it takes less time and less data to have a result. I don't have all the learning phase to have an answer. So I think it's an advantage comparing to deep learning approach.
Yeah, so it's not just the fact that you can skip the learning approach. I mean, maybe for some application, the learning stage is still fine. But for example, in Pascal 3D, you don't. I'm pretty sure that you don't have this object, this specific object. What is it? A fire? How's it called?
Yeah,
Fire
I don't know.
hydrant?
Yes, fire hydrant, I think. Yes. What you mean is that more or less, but it's really a question for me. What can I do with a deep learning or with a learning that is not based on objects I need to recognize or I need to identify? And what I understand as the little I understand of existing approach is that I can maybe specialize my network to the object, or I can specialize an existing learning approach to the object I am interested on. But yes, I don't know exactly how it is possible and how it really works.
Mm-hmm.
So yes, and I think that, as I said to David before, I think that in some application, having the learning phase is not so adapted or interesting to what I want to solve.
Clearly, that's true. But in the case of your target application, so that's,
yes.
if I remember correctly, so that was you had a car driving around in the city.
Yes.
So in this case, it's fine to have a learning stage.
Yes, I agree. I totally agree that there is a lot of work that have been developed on common objects to recognize, and this is exactly why for the work with Thierry on multiple video analysis, we have used these tools because we want to recognize cars, persons, etc. And so it seems the easiest way to do this task.
But what I mean, so these tasks are relatively standard in the sense of detecting cars, detecting pedestrians. There are standards, and then there is a lot of training data. But if you want to focus on specific objects, so there was a pictures of the trash cans around Toulouse or you are probably not going to find training data of these specific.
Yes,
tasks.
Exactly.
So that's where your approach is interesting. Actually, you don't training data, and plus the project, if I remember correctly, that was not really the correct trash cans, but trash cans with deformations or vandalized.
Yes.
And you are always going to. It's not possible to have training data for this.
Yes. Okay.
So that's I think that's really the advantage of your work. And this kind of approaches.
Okay.
So this being said, I would say that, and that's what you already mentioned, a combination of the two of this kind of approaches and deep learning is probably the right approach, because that's you're never going to find the training. If you want to focus on a real problem, not a benchmark, you will always, or you will never have the right training data. But it's true that deep learning also works well once you have the training data. So you can imagine generating training data maybe with your techniques or something like that. I think
Yes.
that's what probably a right approach. So
Okay.
Okay, so I will not torture you more with machine learning.
Thank you.
But okay, I think you agree that it's important, but I think you should still stick to your general approach, but introducing machine learning or deep learning at some point, but really keeping the advantages of your current
Yes,
approach.
yes. It's really the idea to
Yeah.
continue
So,
working, but to be aware of what exists and how I can include it in my techniques.
but you have to be aware of the advantages of your own work. So
Okay, thank you, thank you.
But no. So that you have to understand the limits of the two.
Yes, exactly.
The two approaches.
Mm-mm.
So, and if I move to the 3D reconstruction, so you had this work on the stereo reconstruction and also this on the future work, the guaranteed reconstruction. So for the stereo, for the work you already did, you assume that you can predict the perfect disparity map in a way. Is it always possible? So especially on the Middlebury dataset, do you think it's always possible to predict the perfect, or to, given your two images, predict the perfect disparity map?
So your question is that do I think that it's really possible to have a perfect disparity map?
Mm-hmm.
It's what I hope, but I cannot guarantee that I have the perfect. And I think that for this work, what I want is really to try to have the perfect one and to try to indicate which data I have to acquire to improve. But sure, I think that there are some parts that will be always difficult to reconstruct. If it's occluded, for example, you can manage to estimate in the best way possible the part that you do not see. But if it's still occluded in all the images, it will be a little bit difficult to estimate it correctly.
What I mean, so it makes sense for this new work if you have an active approach. In the case of the stereo reconstruction in Middlebury, if I show you the image of a white wall, for example, even two images, which is perfectly clean, it's going to be difficult to reconstruct.
Yes.
And more generally, if you have a uniform area, so I guess you can imagine that you have actually a family of 3D scenes that correspond to your two images, no?
I'm not sure I well understood. Can you rephrase?
So, maybe there are multiple scenes, 3D scenes, which are going to generate the same stereo pair, for example.
Yes.
So, yeah. So maybe,
Yeah. So the question is, how can I work with this kind of stereo images?
Exactly, yeah. So maybe this kind of ambiguous data.
I try to imagine the kind of, yes, okay, we can have the perfect white world. I try to imagine which kind of scenes it represents, because I have in mind this image of the capital, and so it's clear that at some parts it's difficult to do the matching because it's quite uniform. But I think if you change the scale, I also think that if you had some geometric assumption, you can also solve the problem. But clearly, you cannot solve the problem with a simple correlation-based matching. I agree. So the idea is really to try to take the advantage of multiple constraints, multiple aspects, photometric but also geometric. And the changing of the point of view normally should have, stereoscopic. It's clear. It's just a small displacement. But in the case of this reconstruction, we imagine that we can have a very a movement that is more important, that we can rescale, etc. So I think that at the end we will manage to have something that helps to reconstruct the scene.
But so can you give us a little bit of the how this next based view algorithm works, and how you are going to apply it or develop it for this new work?
I think that first measurement is the density of the mesh that we obtain at the end give us an indication of the quality of the reconstruction. So in the example I have shown, the mesh is really badly defined, and in the areas that are not well reconstructed. So this is a kind of measure that we can use.
Could you also estimate the uncertainty of the reconstruction?
Exactly.
Example?
Also the ambiguity, for example, I think. Yes, when we have
because in your stereo algorithm, so you have these multiple hypotheses. So couldn't you use it?
Yes, definitely. Yes, the ambiguity of the answer, the ambiguity of the matching, or the imprecision, I think. We can use this kind of measurement, definitely.
Because that would be a way to, so where you have a large uncertainty,
yes,
you could,
yes.
And maybe one more question, so that's which is also related maybe to your long-term perspective. So I really like this idea of stories that you use to match the multiple views.
Okay, so this is
with the cameras.
So this is about this.
Exactly, yeah, and to resynchronize. So do you plan to extend it? I don't know, you could imagine having more events or more so different occurrences. And I feel like it's related to your long-term perspective with 2D and 3D representations. Or do you plan to continue working on this work?
Yes, I really want to continue working on this work, and I already mentioned it in the perspective, but in this presentation, I just show the aspect of the moving objects, but I think that I should also combine it with the background study. And in fact, we already work on integration of the background. And yes, in this work, I only focus on the different elements that appear at different instants, but I did not really analyze the concept of event. It's everything is treating at the same with the same importance, whereas we know that if there is a sudden event, it will be maybe more reliable to identify the connection between the different videos. So definitely we want to continue working on that aspect. I have to mention that, I don't know if I do it correctly or clearly in the manuscript, but this project was for European project for helping criminal investigation. So the idea was, so the idea was really to help the investigator to find the right view of, imagine a man that is suspected to have committed a crime, and they want to follow him in the different cameras and to understand what he have done the days before his crime, etc. And so we really focus on that point of finding people, cars, and the different views. But in fact, we have in mind that this kind of tools for helping navigation in multiple videos is not useful only for criminal investigation, but for many other applications. And so, yes, we try to continue that work with submitting other projects about that. Yes, and integrating also. Really, at the beginning of the project, we are interested of camera videos that are taken from a smartphone, because you know when you have a bomb attack or something very important, people use their smartphone, and so we are also interested of really integrating this kind of devices. But you know, it's very difficult because the camera is moving, and so it was.
The registration problem is supposed to be solved, but it's not.
Yes, totally. So this is why we first made the assumption that the video are static, but definitely it have to be investigated.
Even with static cameras, it's
already difficult.
Remains interesting. So that's it's already difficult, and it remains interesting because you also have.
Yes. And I don't mention it, but I have a starting collaboration with a company in Toulouse, and they have cameras on, I don't know how we say it in English, you know, on the public lighting. And so it's fixed camera. And yes, they were very interested by what we have already developed for this project. And I think we can do a lot of things.
And so what kind of events would be interesting in your case? Exactly.
I don't know, maybe a crowd movement that is unexpected. Yes, I think of the bombing attack because this was the subject of the project, but I think it's not so. Yes, it's quite rare normally. So yes, something that appears really suddenly that is not expected in the scene we are looking at.
Oh, yeah. But if you want to synchronize the cameras, maybe just more mundane events would be useful. I don't know if a person enters a car or something like that. Would it be interesting to synchronize the cameras better?
I'm not sure I understand. Sorry, can you repeat?
So there is the one advantage of your approach based of stories is also that you can synchronize the cameras. So if a person enters a car, for example, that's an event which is maybe relatively easy to detect with deep learning methods, for example. That could be that because that's very short in time, so that you could use this kind of thing.
Yes. That was also one of our ideas. To something that what we call an event. It's something that combine the apparition of the action that do not appear in most of the time.
Maybe so just also to extend a little bit, and so for the 3D reconstruction, what you did manually could also be interesting to do to extend. So you mentioned that you were using cars for the registration of the cameras. Could you extend that, or based on, because that's so even for human it's difficult to match feature points in these conditions because it's very wide baseline. What you did naturally, so matching objects, is that something that you could do more automatically?
Right now,
No, not right now, but in the future. So that's you have a full PhD thesis.
Okay. So how can I automatically try to match this kind of scene that I have shown in this slide?
Yes, exactly. Yeah. Because the way you did it in manually, is it something that you can make more automatic?
Honestly, I think it's a bit difficult, and this is why we really do not try to do it, because it was at the starting of the PhD that we do that.
That's fine. Yeah.
So we can, but it was not exactly the subject of the thesis, so we cannot also focus on that aspect. Sure. I don't know, maybe we can imagine that as we now we are able to recognize the area of overlap, more or less, in the different camera. We can imagine that we focus on this areas that we have identified in order to retry doing the automatic matching. But not maybe, I think it's really difficult to detect points of interest that are really repeatable in this kind of data. Maybe by pairs, I think we also try that. But maybe a dense matching is more appropriate in order to maybe after to post-treat these answers, to try to do something. I don't know, it's I just try to answer to your question. I don't know, it's a good idea.
No, but since you manually use the cars, for example, maybe you could also, the method could use instead of just feature points, could use the cars.
Yes, but in this example, we are able to identify the car, but we are not able to register the car. You don't know that we have cars, and we, and we don't do the exact matching. And I think it's difficult, and this is a good example of how it is difficult, because all the cars are more or less the same color, more or less the same shape.
No,
so
that's true.
Yes.
Yeah, so that's it's interesting to see that the problem is not solved. Still.
Yes, it's still open.
Yeah, it's still open for in real applications. Yeah. Okay, but so that's that was very interesting. Yeah. So I will stop here. I think we're already pretty late, but thanks a lot. So yeah, congratulations again. So that's
Thanks.
very
Thank you. Thank you.
Thanks.
Thank you, Vincent. So I propose to change continent. So Yihong, if you have some questions, please ask them now.
Okay. The presentation is very clear. I want to ask a question about the curvilinear features. It's similar as Professor Vincent. I see this method has been used to compute object pose. So I would like to ask, how about the speed by using curvilinear features for making 2D and 3D matching? Can it be used in large scenes or large environment?
Okay, it's true that in this work we really focus on some specific objects. So we suppose that we have. So normally we suppose that the user is taking a photo, and then we are able to have a bounding box around the object, so like this. And we also suppose that we have these 3D models, and we focus on the 3D models. So if I well understood, your question is it applicable in a large scale scene? So what I can say is that I also use this curvilinear saliency for insect segmentation, and it was also interesting because it really highlights the interesting contours of the insect in my image, but it's not really a large scale image. So I think that normally it is also interesting in this kind of scenes. But I have to be honest, I did not really test it on this kind of scenes. But yes, I think it can be used.
If it used in object pose estimation, has it been tested in AR, augmentation reality? I think the object pose is very closely related with AR, a very interesting application. If the computed pose is used in AR, it's clear to see the matching accuracy. Also, it's an interesting application.
So I'm not sure I well understood, so I will try to rephrase. So you ask me if this kind of detector and this kind of tools for matching can be useful for pose estimation in order to have some augmented reality application. Is it your question? Or,
yeah, has
yes,
it been tested in augmentation reality?
I think of your question. I will answer.
In your experiments, it is used in AR? It is tested in AR?
No, I did not test this kind of approach in this kind of application. Yes, and I don't know exactly. I'm not sure I well understand in which sense you can imagine to use it in this kind of application. I'm sorry, I do not manage to answer to your question. Can you give me more details maybe, or? Okay. Yeah. Just to maybe to try to answer in this problem, I want to estimate the pose because I have 3D models, and in order to be able to compare it in the best way, I need to evaluate the pose. So this is in that sense that this work is related to pose estimation.
Okay. Okay, thank you.
Okay.
I have no questions.
Okay, thank you.
Thank you very much, Yvon. So, next person to ask questions would be Ferran.
Hello, good morning. Can you hear me?
Yes.
Okay. So let me start by thanking you for the invitation. It has been very nice to be able to read all this document. Very nice work, very nice document, very nice career, very nice exposition altogether. And in the several aspects that I think that the jury is supposed to be analyzing. And let me start talking about your pedagogical phase, let's say. It's impressive. I mean, you write and you speak very well. You are what I think it's called a natural. It seems that you have been born for teaching, and this is something that is very remarkable. My French is good enough to have been able to understand all the questions that was given in French, And the synthesis that you have done of all of them, it was very nice. I can imagine you in class doing exactly the same, and that's usually very helpful for students. So I have been in a few HDRs before, and I'm always wondering what they have to assess here. But for me, it's clear that there are a few aspects that we should cover. And in your case, having in mind that you have this dimension, or this teaching dimension, I want to ask you a few things. Two, let's say, two different topics dealing with teaching. You have been defending and even proposing a flipped class with your presentation. And okay, my understanding of a flipped class is that students learn, or let's say, study first a set of documents or some kind of information that you have given them. Then you have a second class in which you answer. Okay? They put questions and you answer their questions. And my doubt here is double. First, is that technique scalable? I mean, if all the topics that the student has in one semester use the same kind of teaching technique, is that load that represents for a student acceptable? And the second one is flipped class can be used at any time during the studies in the curriculum. It's just for the first years, for the last years. And if you have the students still online and you want to ask them about the load, you can proceed.
Okay, thank you for this very interesting question. So to answer about normally it's a flipped class for the students in the third year. So it means at the last year of the school. And there are only 30 students. So to answer to the first question, is this scalable? Honestly, I don't know, but it was possible for me to do it for this small class. And I'm not sure I'm following all the, how can I say, the classical way to do this flipped classroom. But I can explain to you how I decided to change my classroom in a flipped classroom. So this classroom is for students who want to specialize in computer vision tools. So they are quite already motivated by the subject. However, when I start to teach at school, I have a classical lesson, and I try to transmit to the student as best as I can all I know about these tools. And so I write the document that I share with you. In fact, some part of the document, in French in particular, are really some part of my class that I give to the students. And so I was very disappointed because it seems that the students like the teaching, but they do not really participate. And when I have the exam, I realized that they do not really understand all the concepts I want to transmit. So I was really disappointed because I work a lot to make a clear document and to explain it clearly during the lesson. But finally, the result is not as good as I expect. And I understand at that moment that it's because, okay, I think that the students are interested, but finally it's just me speaking, me explaining, and they are not really involved in the learning. And this is why I changed to a flipped classroom. This is the reason I changed. And to answer to the other question, I think that it's really interesting to teach like that, but we cannot use it for all the things we need to teach. I think that, in particular, when the starting of the school, I think it's not totally adapted, and we need to have some more, how can I say it? It's necessary maybe to give some help to the student and to be very directive, and then step by step we can give them autonomy and involve them in this kind of teaching practice. So yes, but I have to admit that this is all my reflection, and I did not experiment that.
That's what I was looking for. I was looking for your reflection. I mean, why you decided to do so. Okay, we could continue with this line of discussion, and even more in the context that we have right now due to the virus. But let me move to another thing that really interests me as well, and I want to hear also your opinion on that. How are you including deep learning in your computer vision curriculum? I mean, at this moment we could skip, if we want to go for the best results, we could skip all the introductions and go just for the nice network that performs the better whatever, segmentation, motion estimation, whatever. So how do you handle that?
So your question is
how are you dealing? Okay, my feeling is that you really believe on the let's say basic concepts of computer vision, and right now, due to the results that deep learning are obtaining, you could skip all the discussion about the basics of computer vision and go directly to present the networks that perform the best for each one of the problems, computer vision problems. So how do you handle explaining the basics and introducing the best results?
I think that yes, it's important, the results, but the way you obtain the result is also important. And the problem for me, it's really my point of view, is that if I show the deep learning approach results, I was not able to really explain why it obtains so good results. I mean, explain in the sense, where does it come exactly, and how it is related to some intuitive comprehension of the scene. So I think that, okay, it's nice to present what works well, but if you don't really understand to what it is really linked in the image and why it works so well, I think it's not so interesting. But my goal for my goal
fully agree,
really,
but you are not telling me how do you solve it. I mean, how do you do it? I fully agree with you, but now, then, in your class, how do you do?
I think that I try to be, how can I say? I try to interest the student to the basic tools, but I also give them the opportunity to experiment deep learning tools. And this is a part I do not really discuss this morning, but I do the flipped classroom, but I also have a project-based learning. And this year in particular, in this project, I include a deep learning aspect. So you know, I try to manage the two aspects and to still be attractive for students by using deep learning. And at the same time, I try to show them how it is still interesting to understand the classical computer vision tools. Do you?
Okay, I don't know if it's right or wrong, but we are doing the same. At least
okay.
Okay, so let me go to other things. Let me go to discuss the path of your career. Okay, so as far as I have understood, you are having projects of two different types. If you want to put a slide, put the one in which appear all the students.
All the students? Okay.
The students, because with the color,
this one?
exactly.
Okay.
I think it's this one, because with the color you are already coding where the funding comes from.
Okay.
No? I mean, it
yes,
was,
yes.
So,
exactly.
So the point is, my point is, how are you planning your career, and how would you like to do it from now on? Because here you have, as far as I have understood, some projects that you have proposed, so you have you are reactive, I mean proactive, and you have some projects that industry has proposed, as far as I have understood, so you are reacting to a proposal. That's one axis. So, and the other axis is PhD postdoc. Okay, So in this plane, or with these ideas in mind, how would you like to continue your research from now on?
Okay, so when I write the habilitation, I make a resume of my professional life. And I realized that, as you mentioned, I was really dependent on some external events, having collaboration with industrial, having some projects in the team. And this is why, before I finished writing the document, I decided that I want more academic research. And this is why I was thinking of asking for academic grants. And during the writing, I write a subject with my colleague Geraldine, and it was really in that spirit. I really want to keep always an academic research, and I also like the fact that I have some real application. So I think that my hope for the future is really to have both academic research that are really related to the subject I want to develop, with no thinking about how it will be really applied to real application. And in parallel, I want to develop some really concrete, real applications, and I try to, as far as I can, I will try to have some collaboration with the two aspects. But I really think that I have to take care of having a really academic part, both with an applied part that is really related to the subject I am interested on. So I don't know if it answers well your question.
No, for sure it answered. I mean,
okay.
and very well as well. Okay, thanks. Let's move now to more technical things, if you don't mind.
Okay.
Can you go to slide 22? I think it's the one I want. It's between 22 and 26, but let's start with 22.
22.
Okay, I like it very much, this the example you have given there. While I was thinking, have you been able to, let's say, know which kind of clues can be used for optimizing and which kind of clues can be used for post-processing? Do you see what I mean? I mean,
I'm not sure.
Okay, when you were talking about the constraints that you have to introduce in order to improve your results, you were saying that there are two main ways to do it, and one is including them in the optimization, and the other is using them as post-processing. And then you, close to what I was going to ask, you put this example that I think it came from a student question about if color was useful or not in order to improve the quality of the results and so on. And then I move one step backward. Do you have an idea of which constraints should be used when optimizing and which constraints can be kept for the post-processing step? Is it clear, my question?
Yes, your question is clear.
Okay, perfect.
No. I try to answer. Yes, it's clear. So your question is that, for example, above the constraints I have listed in this slide, which one is most adapted to the global optimization, and which one is more adapted to kind of post-processing? It's
exactly.
More or less
and if you know why, then it's great.
First of all, I think that they both can be used in the two different way, but it depends of the kind of optimization you have. And I think that some of these constraints are not really easy to apply in the, in this formula. And the way you can formulate it, I think it's not easy to optimize that. So yes, it depends on the optimizer you will use. And in fact, in all my work, I I mostly use all these constraints as a post-processing instead of including it in the global optimization.
Okay.
So,
because of the complexity
yes.
of the optimization.
Yes, yes.
Okay. Can you move? I think it's 26. All this discussion when you were.
This one?
Yeah. Here you have said that you wanted to introduce semantic segmentation, but you have proposed that just after showing an example in which all the objects are the same. And I don't know, how do you want to introduce semantic segmentation in your multiple matching technique?
I think it is the same way I want to introduce segmentation, but with an information more is that the semantic. So if I you know, sometimes you have the edge of the regions, but if you don't know which kind of regions you are observing, maybe you will penalize if you choose the regions that is near these regions, but in fact it's the same object. So I mean, for me, semantic is really the sense of the regions can be also introduced in the way to match the pixels.
But then you mean that if I have detected a person and a bicycle, I know where they should be, one related to the other? Is that the kind of semantic segmentation you want to introduce?
Yes, I think. I'm not sure I well understood what you said, but yes.
The semantic segmentation will give you regions with a semantic meaning, but I don't know if you want to use the relation between these semantic objects or something different that comes from the semantic segmentation. I don't know if you want to improve your regions or relate the regions due to the semantic value that they have. You see? I don't know if you want to better detect the person and the bike, or to use the fact that you know it's a person and it's a bike to do something with it.
I think the both aspects. I imagine the both aspects of the semantic. I mean, you say it's a kind of I don't know how to say in English. To reinforce the decision by using also the semantic information, and
okay.
but it can be it can be used at different level, as you said.
Yeah. Okay. When you were presenting all these parts and when reading the document, I thought she has all the tools to attack a problem on remote sensing. You have produced all a different set of tools that can be used in an area that I didn't see in the document, which is remote sensing. And then today you have presented a new project that proposes to use this kind of techniques and so on. So can you go to the slide 35? The new project that you have, this one, exactly. Okay, this project can be a paradigm of all the things that you have been, or plenty of the things you have been proposing through your career and in this presentation. And I'm wondering if you have a good understanding of the problem that you are going to handle. And I'm not talking about the images themselves, but the complexity of remote sensing and drone imaging and so on. If you want to be able to compare data obtained from different sensors with different satellites and using, for instance, drones and so on, you're going to be facing a lot of technical problems, a lot. It's a very interesting project, the one that you are presenting here, but please take care of reading a lot about the way in which all these problems that you can have by, for instance, combining the stripes that generate a drone, or calibrating the drone at different days, or trying to have the same more or less view in the same area at the same time of the different sensors, oh, this is a nightmare.
Yes, I have an idea of this difficulty, and this is
great.
yes, maybe it's a project. I try to be ambitious, but I know that there is all these difficulties, and in the partners and the different person involved, there are some experts on all this kind of data. But yes, I think that we will work step by step, and clearly maybe my idea is to first try to extract the information we are interested on each modality, and then we will try to work on how to combine them. Yes.
Have you already fixed the type of sensors that you're going to use? Multispectral, hyperspectral, whatever?
We will use images acquired by drone with a classical camera, and also with a thermal camera. Yes, it's a good.
Yeah, I understand it. At least.
It's okay. No, it's a good right term, and I was not sure. Yes, for the moment we only think of these two kind of sensors, and then we will have a fixed camera, and we also want to use satellite images. This is a different kind of data we imagine for the moment, because this is the data we are sure we can access.
Perfect. Okay, that was all on my side. Thank you very much for your presentation, and thank you very much for your accurate answers.
Okay, thank you. Thank you.
Thank you, Ferran. So 2 more to go. I think we try to be relatively brief. So I'll go first. I had noticed several questions, but the time is running, so I'll brief, maybe.
Okay.
If you go to the very beginning of the presentation.
Okay.
I mean, slide number 2.
Sorry. This one?
Yeah, you say you want to combine or use all available information in the best possible way. So best possible, it depends on how you define it. So for example, when I thought about a vision problem, I think in different levels. So first, the very best one could do ever if you don't have constraints on computation time, if you have infinite memory. That's if you have no constraints like this, you can really do the best possible. But in practice, we do have these constraints. You have to be in real time, you have limited memory, you don't have infinite data, and so forth. Do you think, do you think that depending on the definition, what it means best possible, you could approach the problems you try to solve in different ways?
Okay. So the question is the best possible way. It's different. It depends on the real application or the purpose I have.
Okay, what's your definition of best possible?
For this work, the best possible way is theoretical. It's really, I don't care about the time or the memory, and I just build that concept on the fact that if I can choose exactly the measure that gives the right answer, I should have this best result at the end. But clearly, it's really just for this subject, and yes, it has to be adapted. And yes, the best way as possible. It means related to the circumstance and the way you want to use it.
Do you think there is a way to prove that it's the best possible, the way you do? It could be yes or no.
I don't know. I will say maybe no. I don't know. I'm thinking of your question. It's a very interesting question.
Mm-hmm.
Yes, for this it was very easy to answer. Yes. But yes, I think that we can measure that aspect if we fixed some constraints. If you know that you can just use this amount of memory or this amount of time, yes, I think you can evaluate what means exactly the best as possible.
Okay. I have a question on one of the perspectives you mentioned about making complete 3D models. So I think Vincent asked already about geometry completeness. I mean, the question is related to this. You also said that you want to investigate photometric completeness. What do you mean by this first? How do you evaluate it? And also, I mean, in the end, it would lead to an active approach, so moving the camera to the next best view. You also think of controlling the lighting, for example, to get better photometry.
Okay, so about the photometric evaluation, it means about the quality of the texture and of the models. Right now, I don't know exactly. I know we just start this month, and we have some papers we want to base our work on that aspect. But right now, I don't know exactly how we will measure it. But I think it's more or less related to the quality. How can I say it? The number of points that represents the piece of scene we are evaluating. But honestly, I won't say something wrong, so I just stop my answer that. And I don't remember the last part of your question.
If you want to include, for example, lighting control in the active approach.
So your question is that do we plan to have active vision? Not really. Not really. No.
Okay. Just for finishing, I mean, what I like a lot is that, I mean, you have done a lot of works. Also in the perspectives, you present lots of perspectives. It's very interesting. Also very original ideas, several original ideas. At the same time, it could be a bit too much.
Yes.
Also, you presented the 3 types of extensions you plan as a continuation of what you are already doing. But say if today you were free from all constraints, I mean, don't go throw away all your current students, they disappear. I give you funding, unlimited funding. What would you really want to do? I mean, let's say, what would you really like to achieve in 10 years? What's most important for your heart,
Okay. It's hard to choose. That's the main problem of my life, I think. But what I really want is all the aspect of matching. I think I present. This is the last part of my document about matching. In fact, it's highly related to my PhD work. I have to admit that since my defense, I try to continue to work on that aspect, and I work a lot with Guillaume, but after that I cannot work a lot because I think I'm quite alone in this subject in the team, and so I also want to work with my colleague. So I think that if I have an extra grant and extra time also, I think I will really like to have a student working on really the matching aspect and really focus on these techniques.
But to achieve what? To achieve what in matching?
To better understand, because I have a lot of ideas of doing matching with superpixels, with semantic segmentation, etc. But right now I have no one to work on that aspect, so I cannot. So to achieve what? A super technique for doing matching, I don't know. Just, yes, it's not for sharing, really a purpose You know, it's really just research. But if I really also, I really want to work on some aspects that are useful for users and humans, and I think that if I can, I will be very happy to continue working on medical applications like I did during my postdoc, and like I propose with the project I put in the manuscript. And this project was rejected, but I really want to work on that aspect. But I have no time and yes, you know, no funds to really work on that point. And this is why I finally choose the subject of the forest, because I have more connection with other researchers for doing this research. But clearly, if I have more time, I will try to develop something more in relation with medical applications.
Okay, thank you. So I hand over to Geraldine for some final remarks.
Yeah, thank you. That won't be any questions. I keep them for the rest until I retire on the rest of the time. I want to, for the team, also on behalf of the team, I want to thank the jury. It's not an easy time to participate in juries, and thank you all for your patience this morning and for being there for Sylvie. I want to stress again, as has been done in the reports and in the remarks of the reviewer, that Sylvie is a wonderful colleague. I won't talk about her personality, that is more personal, but just for being a colleague, she does very well her job in all aspects with her research and teaching. Of course, it was stressed a lot. And I think also for the administrative duty. So she's very, profoundly reliable and very enthusiastic on the things she does. And thank you for that. And I also want to talk on behalf of the research team that we have been welcoming you 11 years ago. I saw that on what you showed us today. So it has been 11 years of really nice time and nice work. And I also want, as a last remark, to stress your reliability, because you have been doing this work during the confinement and despite the confinement. And that shows that we can really count on you, whatever the circumstances are. So thank you for that, and for the colleagues that are here and that are not here, but that would like to be here. Thank you.
Thank you, Geraldine.
Okay, I think this concludes the public part of the proceedings. So the committee, I mean, you stay where you are. Maybe, so we now have to have a little discussion. Maybe you can switch all your cameras on.
Ils vont délibérer ici,
And before continuing, I need a 2-minute break. So see you in 2 minutes.
Oui, c'est possible. Ah oui. Du coup, tu restes pas loin, parce que j'ai accroché.
C'est très bien.
C'est bon, le stream ou pas?
Est-ce que vous nous entendez, le jury?
Je t'entends.
Vincent, oui, je te vois à l'écran. Ok, très bien.
Après, il faut mettre les écouteurs. Non?
Oui. Ok, bon, le jury a délibéré. C'était pas très long. Alors, donc en fait, je demandais à tous les membres du jury de donner des éléments de leur appréciation. Et en gros, on était tous unanimes sur les différents aspects. Donc, comme ça a été déjà dit sur le manuscrit, c'est un manuscrit vraiment impressionnant, en fait, parce que tu as dû passer beaucoup de temps à l'écrire. Il y avait aussi beaucoup de choses à dire. Donc, tu l'as bien structuré. C'est vraiment appréciable le soin que tu prends pour guider le lecteur. Donc, tu ne le fais pas juste pour avoir le diplôme, mais tu le fais aussi pour que d'autres gens puissent apprendre quelque chose. Tu as vraiment de très nombreuses perspectives pour tes recherches. Donc, tu as beaucoup réfléchi. Tu as aussi pris le train, un peu de deep learning, mais pas comme peut-être beaucoup de gens de manière un peu automatique, mais de manière réfléchie. Donc, moi, personnellement, j'apprécie ça beaucoup. Voilà, les personnes, comme ça a été dit dans le rapport aussi, apprécient que tu couvres un spectre assez large dans tes recherches, y compris les aspects fondamentaux, mais aussi tu n'oublies pas les applications. Et ce qui a été beaucoup apprécié, c'est aussi le lien que tu fais entre l'enseignement et la recherche. Donc pour toi, c'est un tout. Il y a le mot compréhension holistique des choses qui a été prononcé plusieurs fois. Donc voilà, tu essayes de prendre les choses dans la globalité et c'est vraiment très fort. Et bien sûr, la soutenance elle-même, ça a été très long, mais tu as gagné la pêche. Tu as très bien présenté, tu as fait des bons choix de présentation, c'était très pédagogique. Et il y avait quand même beaucoup de questions. Et tu as répondu avec précision à toutes ces questions-là. Et voilà, je crois que j'ai dit à peu près l'essentiel. Donc en fait, pour toutes ces raisons, le jury il a été unanime dans sa décision de décerner l'habilitation à diriger les recherches. Félicitations.
Ok, merci. Je crois que c'est la partie la plus difficile en fait, maintenant, les remerciements. Okay, I will say a few words in English for Yvonne and Ferhan, and then I'm sorry, I will finish in French. Thanks a lot, Yvonne and Ferhan, to accept to participate to my jury. And yes, thanks for your questions that were very interesting for me. And in particular, I really appreciate to be able to talk about a flipped classroom that I really love. So thanks for that. Ok, alors d'abord merci, vraiment un grand merci à tous les membres du jury. C'est difficile parce que je ne vous vois pas là, mais voilà, merci beaucoup Samia, David et Vincent pour votre rapport déjà, parce que ça m'a fait énormément plaisir de recevoir tous vos commentaires, tous vos retours très positifs. J'ai vraiment apprécié aussi la séance de questions aujourd'hui, c'était vraiment chouette de pouvoir m'exprimer sur tous ces aspects. Donc vraiment merci, un grand merci. Je suis assez déçue de ne pas avoir pu partager ce moment avec vous ici, et j'espère qu'on se rattrapera en fait. Donc je vais réfléchir à comment on peut organiser quelque chose pour vraiment avoir un échange un peu plus proche par rapport à ça. Merci beaucoup à Peter d'avoir été le courageux membre du jury qui est venu aujourd'hui. Et puis voilà, j'espère que j'ai oublié personne. Et donc merci beaucoup à Géraldine de m'avoir suivi et d'avoir accepté d'être ma garante pour l'habilitation. Il y a vraiment 2 personnes qui m'ont énormément aidée pendant tout ce travail. C'est soit Géraldine, déjà, par tes retours bienveillants, ta motivation, ton enthousiasme. Voilà, c'est hyper agréable en fait de travailler avec toi et ça m'a vraiment apporté particulièrement dans cette période. Donc vraiment merci beaucoup. Je voudrais aussi remercier Luce Morin parce que c'est la deuxième personne qui m'a beaucoup aidée pour l'habilitation. Voilà, j'aurais bien aimé qu'elle soit là aujourd'hui, mais voilà, il y a certains liens de parentalité qui font que ça devient un peu compliqué. Donc merci beaucoup à Luce, parce que toutes nos discussions pour préparer la GR, la soutenance, etc., ça m'a vraiment beaucoup aidée. Donc j'ai eu plein de très très bons conseils qui m'ont beaucoup aidée. Donc vraiment un grand merci pour ça. Grand merci à toutes les deux, vous avez vraiment été mes bonnes étoiles en fait pendant cette préparation. Ok, après j'aimerais remercier, il y a des personnes qui ont été vraiment très importantes dans ma carrière, qui m'ont vraiment bien guidée, bien accueillie, bien acceptée, et avec qui ça a été un plaisir de travailler. Et je voudrais les remercier. Donc tout d'abord mon directeur de thèse, Alain Crouzil, puisque c'est comme ça que j'ai commencé la recherche, c'est avec lui, et c'était vraiment très formateur. Et voilà, je pense que s'il ne m'avait pas accepté, toute cette histoire n'aurait pas commencé. Donc un grand merci à lui. Je voudrais remercier aussi Isabelle Bloch, avec qui j'ai fait un postdoc à Paris, parce que c'était vraiment génial de travailler avec elle. Et je pense que c'était ma première figure féminine dans le monde de la recherche, et ça m'a vraiment fait du bien pour continuer et pour y croire. Voilà. Donc je remercie aussi pour ça. Je voudrais aussi remercier Jérôme Idier, mon collègue à Nantes, avec qui c'était vraiment génial de travailler pendant toute cette période où j'étais à l'IFSTAR, où c'était parfois un peu compliqué pour moi, parce que j'avais pas beaucoup d'interactions avec des chercheurs en traitement d'image, parce que j'étais isolée. Et donc c'était vraiment chouette d'avoir été accueillie par lui dans son équipe et de pouvoir passer des journées au laboratoire à l'IRSIN. Donc je remercie aussi. Et puis la dernière personne importante dans mon parcours, c'est Vincent, donc Vincent Charvia. J'aimerais le remercier de m'avoir accepté dans l'équipe, de m'avoir accueilli comme il l'a fait. C'était vraiment une très grande opportunité pour moi en fait de venir ici. C'était, il faut le dire, inespéré. Je ne pensais pas revenir un jour à Toulouse et je n'avais pas planifié de revenir un jour à Toulouse. Donc voilà, je remercie pour cet accueil. Et donc j'en profite pour remercier toute l'équipe REVA. Voilà, c'est génial de travailler avec vous en fait, chacun à votre manière, avec votre style. Et je pense que voilà, j'espère vous avoir rendu suffisamment hommage sur mes transparents aujourd'hui. C'était le but. Voilà, je voudrais remercier en particulier les bons conseils de Jean-Denis sur la façon d'écrire une habilitation tout en se faisant plaisir. C'était nécessaire, en fait, c'était un très bon conseil qui m'a bien aidé pour rédiger mon manuscrit. Je remercie bien sûr Pierre, mon collègue Pierre, avec qui je pense que j'aurais pas eu idée en fait de candidater d'ailleurs sur ce poste. C'est quand même lui qui m'a tendu la main alors que j'étais encore à Nantes. Donc je le remercie pour ça et je le remercie pour tous les travaux qu'on a eu ensemble. Je tiens à remercier aussi mon collègue Axel. On n'a pas eu beaucoup d'occasions de travailler vraiment ensemble. J'ai essayé de le mentionner dans les transparents et j'espère que le futur nous permettra de travailler plus ensemble. Je remercie notamment pour avoir relu les manuscrits sur tous les aspects deep learning, parce que c'est lui notre expert deep learning dans l'équipe. Voilà. J'espère avoir oublié personne. Alors après, j'aimerais vraiment dire un grand merci à Thomas pour aujourd'hui, pour toute la technique autour de la rediffusion, de la diffusion. Voilà, je n'y serais pas arrivée sans toi. Voilà. Donc peut-être que c'est vrai que ce matin, ça a été un peu long à se mettre en place, mais franchement, ça aurait été juste impossible si tu n'avais pas été là. Je tiens à dire aussi que vous avez parlé de l'effort que j'avais fait pour guider le lecteur, donc j'avais mis un code couleur, etc. Bon, ça, c'est grâce à Thomas, en fait. La réalisation technique de ce désir de vouloir mettre des couleurs, c'est grâce à Thomas et plein d'autres choses encore qu'il a géré sur les aspects techniques. Donc merci, c'était vraiment... C'était chouette d'avoir ce backup derrière à chaque fois où je me disais, bon, je ne sais pas trop faire, mais je pense que Thomas, il va savoir. Donc vraiment, merci. Et j'en profite pour te remercier au nom de l'équipe, je pense, parce que tout le monde apprécie tout ce que tu nous apportes au quotidien. Et voilà, avec Thierry, on en rigole souvent parce qu'on dit, pourquoi il faut faire ça ? Je ne sais pas, Thomas l'a dit, ok, on le fait alors. Voilà. J'en profite du coup pour remercier Thierry aussi, parce que voilà, tu t'es vraiment beaucoup impliqué dans l'habilitation, dans la rédaction, puisque tu m'as, voilà, t'as beaucoup relu la partie qui concerne ton travail, tu m'as aidé pour les illustrations, etc. Donc merci beaucoup pour ça. Et jusqu'à la semaine dernière où tu m'as dit non, ne relis pas mon manuscrit, concentre-toi sur ton habilitation, parce que Thierry a envoyé son manuscrit la semaine dernière. Voilà. Donc merci pour ça, c'est un vrai soutien. Donc merci beaucoup. Et de manière générale, je voudrais remercier tous mes doctorants. Alors ce matin, il y en a 2, voilà. Je voudrais vous remercier du travail accompli avec vous. Voilà, c'était vraiment chouette de partager ces moments avec vous. J'espère qu'on en aura d'autres en fait. Et par la suite, voilà, c'est déjà le cas en fait. Mais voilà, j'espère que ça continuera comme ça. Je voudrais remercier aussi tous les gens du département qui ont eu le courage de venir m'écouter ce matin et tous ceux qui m'ont envoyé aussi des messages vraiment très sympathiques de soutien. Il y en a beaucoup qui ne pouvaient pas être là, mais qui ont manifesté leur soutien. Donc ça, c'est vraiment chouette. J'ai beaucoup apprécié. Voilà, et pour terminer, des remerciements plus personnels. Hein. Je voudrais remercier tous mes amis qui étaient là ce matin. J'ai reçu je ne sais pas combien de messages. Donc merci à tous. Je sais que vous êtes là, je sais que vous m'écoutez. Ça me touche beaucoup. Et voilà, on fêtera ça ensemble après. Mais merci beaucoup de ce soutien. Et je voudrais remercier ma famille, toute ma famille. Donc voilà, moi je suis dans une famille, on est 5 enfants, j'ai un frère et 3 sœurs, mais on a tous fait nos vies, on a tous évolué, et puis maintenant je peux dire que j'ai 4 frères et 4 sœurs en fait, et on a tous des enfants, et ils étaient tous là avec moi aujourd'hui. J'ai ressenti toutes les bonnes ondes de tout le monde, là aussi j'ai reçu plein de messages. Donc merci beaucoup, ça me touche beaucoup, vous avez compris que c'était un moment important pour moi, et je vous en remercie énormément. Et puis bien sûr, je voudrais remercier mes parents qui auraient voulu être là ce matin. Je sais qu'ils auraient voulu être là. Mais voilà, je voulais vous remercier parce que parfois, la vie, c'est difficile de garder le cap sur ses idéaux. Et je pense que je m'inspire beaucoup de vous, en fait, parce que vous êtes des personnes avec des idéaux très forts. Vous les avez toujours défendus et soutenus. Et parfois, c'est un peu dur parce que quand moi, j'essaie de me mettre à votre hauteur, c'est un travail un peu dur sur moi. Mais au fond, ça me permet d'avancer et de me fixer un idéal. Et je pense que voilà, aujourd'hui, les retours que j'ai eus, ça prouve que j'arrive en partie à atteindre cet idéal que j'aimerais atteindre. Donc, je vous remercie pour cet exemple que vous me donnez au quotidien. Et puis, je remercie aussi mon mari, Ivan, parce que voilà, c'est vrai que Géraldine t'a parlé du confinement. C'est vrai que si j'avais pas un super partenaire au quotidien, je crois pas que j'aurais réussi à écrire pendant le confinement. Donc merci pour tout ce que tu as fait. C'est énorme en fait, et j'en ai conscience. Merci. Voilà. J'ai fini mes remerciements.
Ouais. Je sais pas où on peut.
Attends, je vais essayer de. Je sais pas si.
Voilà en fait sur la caméra.
Hein? Je sais pas, en fait on voit. Je sais pas où il. Hop, voilà. Je sais pas si vous m'entendez encore. Je vais enlever le micro. Hop. C'est bon ou pas? Hein? Je pense que tu peux couper le stream, ouais.